I can see Mohan. Good morning, Mohan. I'm expecting some more students to join this. So students, this is the brief introduction about me. I've been teaching in this domain since many years, and my subjects of interest are engineering mathematics, signals and system, and analog circuits. Coming on to this screen, on your screen you can see the faculties, all senior faculties from different branches, EC, electrical, instrumentation and computer science. We are bringing for you Maha marathon for different technical subjects. One more announcement, students. Your favorite mechanical engineer, faculty, teacher, mentor Dheeraj Sardana sir will be coming live on 10th of Jan at 7:30 p.m. and he will be conducting a session on BYJU'S exam prep. Yes, this is our app, and on this app, on our app, he will be conducting a session how to ace GATE 2024 with college or college job. So if you or some of your juniors are aspiring for GATE 2024, then you can guide him, you can guide them and join this session. Satyashri, good morning. How are you? Rakesh Talreja sir will be coming for general aptitude for GATE 2023. 15 marks in just 15 hours. This is the theme, and he will be taking. It means he will be taking up a big marathon for 15 hours and making you comfortable in general aptitude. And this is the session I will be coming live along with Rakesh sir, and we will be conducting 2 days maths marathon. It means near about 24 to 30 hours we are coming live, and we will be covering entire engineering maths in 2 days, Saturday and Sunday. Yes, weekends for GATE 2023. So students, Mohan, most probably next to next weekend. It means something around 21st, yes, 21st January or 21st January and 22nd January. Check. Please concentrate. Students, we want to evaluate this integral. Now you may be thinking that this integral may be the part of integration, that is mathematics, but definitely we will be solving it using the properties of Fourier transform. See here. What I am going to do now, I will be just giving you some idea. If it is e raised to minus a mod of t, what is its Fourier transform? Tell me. Twice a upon a square plus omega square, correct? As I can see here, that I am getting omega square plus 4. I can see here that I am having omega square plus 4 here. So here a is 2. So put a equal to 2 here. E to the power minus 2 mod of t. Its Fourier transform will be 2 2s are 4 upon 4 plus omega square. Correct? Now students, this is our x of t and this is our x of omega. Now by Parseval's energy theorem, how can we proceed? See, by Parseval's theorem, energy of this signal Ex is integration from minus infinity to infinity x of t modulus square, and the same energy can be calculated as 1 by 2 pi minus infinity to infinity x of omega modulus square. So students, of course, my friend, study material, of course, but you need to solve questions along with us. Now 1 by 2 pi minus infinity to infinity x of omega modulus square. X of omega is this one, its modulus will remain same because this is already positive. Square it, you will get 4 square 16 upon denominators square, and this is equal to energy. So energy of this signal will be how much? इस सिग्नल का एनर्जी कितना होगा? Yes, e raised to minus a mod of t. Is it a by pi or 2a by pi? I just remember that this is 2a by pi. We'll just use it as of now. So now pi gets cancelled. Sort it out. E to the power minus a, in fact minus infinity to infinity. Good morning, Joy. How are you? Minus infinity to infinity. Yes, its square will be e to the power minus 2a mod of t. So this is the formula for calculation of energy of this signal. E to the power, yes, square of this, e to the power minus twice a mod of t. Comfortable? Now, since this is an even function, you can just multiply by 2 and take the integration limits as 0 to infinity. So this will be e to the power minus twice a t dt. And tell me, what is the integration of this one? E to the power minus twice a t upon minus twice a. So if you just put 0 to infinity, what you will get? 2 cancelled. E raised to minus infinity is 0. Lower limits minus. E raised to 0 is 1 upon minus 2. So we are getting 1 upon a as the energy, correct? Have I done the correct calculation? E raised to minus infinity 0, e raised to 0 1. So 1 upon a is the energy. One upon a. This pi will remain as it is. Now this integration 16 can be splitted as 8 upon this 4 plus omega square whole square d omega. 2 is cancelled and pi is brought to the numerator. So pi upon a should be the answer. Comfortable? Now coming on to the correlation part. Correlation is a comparison tool. Whenever we need to compare two different signals, we use correlation. Correlations are of two types: autocorrelation and cross correlation. Okay, so we have separately defined correlation for energy and power signals, and we are utilizing the concept of correlation more in communication system. Here in signals and system, we will be just covering its calculation aspect and its relation with convolution operation. So students, whenever you have this type of signal x of t as some constant times cos omega naught t, then its autocorrelation function of x of t, which is denoted as r of tau, this will be always a square by 2 cos omega naught tau. This is the format useful for you. You can directly utilize this as the autocorrelation function of a cosine function. So autocorrelation function is being asked for this x of t. So this is, what is the coefficient of this first cosine term? पहली cosine term का, first cosine term का coefficient कितना है? 1. So 1 square by 2 cos 2 pi tau. So there is one more term. So linear sum of the second term with this term. So 2 square by 2 cos 4 pi tau, and just simplify this. You will get 1 by 2 cos 2 pi tau, and 4 by 2 is nothing but 2 cos 4 pi tau. So this is how we can write quickly the autocorrelation function of this cosine function. Can sine function be an autocorrelation function? No, because for a function to be correlation function, it must be even function. It must be even function. Number 2, it must have a positive Fourier transform. Number 3, autocorrelation function at tau equal to 0 should be maximum. Should be maximum. So when I ask you sine function, can it be sine function? Can it be autocorrelation function? It cannot be autocorrelation function because it is not an even function. Okay, and that's why we just ruled out that how to write uh, sinusoidal function as autocorrelation function. Okay, now see this. We need to find autocorrelation function of this signal. So one very important property that students, we have a signal x of t. Autocorrelation function of x of t is denoted by r of tau, and this is actually equal to x of tau convolution with x of minus tau. This is how we calculate autocorrelation function very quickly with the help of convolution operation. Is that very clear? So if we take the Fourier transform of this r of tau, then x of tau's Fourier transform, let us say x of omega, multiplied, convolution changes to multiplication. Fourier transform of x of minus tau will be x of minus omega. Great. So students, we have this signal x of t, e raised to minus 3t. I will just replace t by tau, e raised to minus 3 tau u of tau. So its Fourier transform will be 1 upon 3 plus j omega, correct? Yes, sir. If I replace tau by minus tau, I will get see, this is not this should not be even function, Nitesh Yadav. Its autocorrelation function should be an even function. That is the logic. Okay. Yeah. So e raised to 3 tau u of minus tau. You just replaced tau by minus tau. It means folding in time domain happened. So reversal in frequency domain also happened. So this is your x of omega and this is x of minus omega. So students, Fourier transform of r of tau, let us say it is r of omega. This will be the product of x of omega and x of minus omega. So a plus b, a minus b, a square minus b square. So j square is minus 1. So 3 square plus omega square. So when you take inverse Fourier transform of this quantity, you must get r of tau. And this will be e to the power minus 3 mod of tau upon twice a, where a is 3. So 6. So this should be our answer. So this is how we can calculate the autocorrelation function with the help of Fourier transform and convolution property of Fourier transform. Comfortable with this? Now see this question. I'll just give you an opportunity to read this entire question. I'll hide myself for some moments. They have defined a function g of t. G of t कितना है? G of t is e to the power minus 8t u of t. Then, good morning Payesh. Now see here, define x of t, which is convolution of g of t with itself. Acha ji. So x of t is g of t convolved with g of t. This is what they have mentioned. And they are asking x of t at t equal to 1 by 16. Comfortable? They are asking x of t at t equal to 1 by 16. So how we can proceed here? Very, very simple. I will take the Fourier transform of x of t, which is x of omega. Fourier transform of g of t will be g of omega. Fourier transform of again g of t will be g of omega. Great. So students, Fourier transform of this g of t is 1 upon 8 plus j omega, correct? And this is our g of omega. So x of omega will be 1 upon 8 plus j omega whole square. Comfortable? So if you would be able to take the Fourier transform of inverse Fourier transform of this function, then you are done with your requirement. And this will be nothing but x of t. So find out this inverse Fourier transform, and in that result put t equal to 1 by 16. You will get the answer. Comfortable, students? Now see, e raised to minus 80 u of t. क्या होता है इसका Fourier transform? 1 upon a plus j omega. If you multiply by t, e raised to minus 80 u of t, then its Fourier transform will be j times d by d omega Yes, Ravi. See, convolution of g of t with itself means g of t convolution with g of t. That is what they have mentioned in the problem. That's what we are following. तो सवाल में दिया है वही हम फॉलो कर रहे हैं. Now, j as it is, differentiate this. So minus 1 upon denominators square. A plus j omega derivative will be simply j. Now please concentrate. J into j square is minus 1 and minus plus. So 1 upon a plus j omega whole square. This is the Fourier transform of t e raised to minus 80 u of t. Correct? Okay. So see this term. इस term को ध्यान से देखिए, घूर के देखिए. See here, this term. So x of t will be what is this? A is 8. So t e raised to minus 8t u of t. This is our x of t. Now what you want? You want x of 1 by 16, है ना? X of 1 by 16. So in place of t, 1 by 16, e to the power minus 8, 1 by 16. Very good. And then u of 1 by 16 will be 1. So 1 by 16 e to the power minus 1 by 2, that is root e in the denominator. So 1 upon 16 root e should be our answer. 1 upon 16 root e. 1 upon 16 root e. Is there any option like this? Yes, I can see that option. What is that option? Option B. Comfortable? Students must respond. Everyone should respond. Next. Similar question. In this question, they are asking about the energy density spectrum of g of t. Great. So students, g of t's Fourier transform is g of omega, and energy spectral density of g of t, this is just equal to g of omega magnitude square. Now, what is this g of omega? G of omega will be the Fourier transform of this function. It is 1 upon 8 plus j omega. Can you find out its magnitude? Yes, of course. Its magnitude will be 1 upon under root 8 square plus omega square. Correct? So students, when you square it, this square root sign will be cancelled. But we want this at f equal to 0. Frequency की value 0 पर चाहिए. F equal to 0 means omega equal to 0. So you will be getting 1 upon 64 plus 0. 1 by 64 is our answer. Option C is the correct answer. Can I have your response on this? Next. See this question. It looks similar, but they are asking a different quantity here. Please go through this. What is this? What we want? We want y of tau at tau equal to 0. So what is this y of tau? Y of tau is correlation of g of t with itself. Means autocorrelation function of g of t. Great. So y of tau will be g of tau convolution with g of minus tau, like this. Great. So y of tau. What is g of tau? Do one thing. Fourier transform of y of tau will be y of omega. This will be g of omega multiplied with g of minus omega. G of omega is 1 upon 8 plus j omega. And g of minus omega is 1 upon 8 minus j omega. So y of omega will be one upon 8 square plus omega square. So if I take inverse Fourier transform, I will get y of tau. It is 1 upon twice a e to the power minus a mod of tau. Correct? 1 by 16 e raised to minus 8 mod of tau. Great. So what we want the result at tau equal to 0. When you put tau equal to 0, you will get 1 by 16 as the answer. Comfortable, students? 1 by 16 is the answer. Can I have response from everyone? Ravi, what they are asking, beta? They are asking that y of tau at tau equal to 0. What is y of tau? They defined in the question as y of tau is correlation of g of t with itself. Correlation of g of t with itself means autocorrelation function of g of t. So y of tau is autocorrelation function of g of t. What we have done, y of tau equal to g of tau convolution with g of minus tau. This is now. What is the Fourier transform of this function? 1 upon 8 plus j omega. When you fold it, what you will get? 1 upon 8 minus j omega. So on multiplying these two, you are getting 1 upon 8 square plus omega square. And inverse Fourier transform of this function is 1 upon twice a e to the power minus a mod of tau. And at last we want the result at tau equal to 0. So we have substituted tau equal to 0. Now they are asking for cross correlation function. CCF stands for cross correlation function of x of t. Cross correlation function of x of t. Cross correlation function of x of t with y of t. Acha ji. So cross correlation function of x and y is denoted by rxy. This will be x of tau convolution with y of minus tau, like this. This is the format for calculation of CCF. If you take Fourier transform, then you can write here Fourier transform of rxy of tau This will be Fourier transform of x of tau multiplied with Fourier transform of y of tau. Is that clear? x of omega इसका फोरियर ट्रांसफॉर्म बताइए. e raised to minus t u of t. Its Fourier transform is 1 upon 1 plus j omega. And y of minus omega. What is y of omega? 1 upon 3 plus j omega. This is y of omega. We want y of minus omega. So it is 1 upon 3 minus j omega. Now here we supposed to do partial fractions. Find inverse Fourier. Okay. So what we are doing? 1 upon 1 plus j omega. In fact, I should write 3 minus j omega first plus 1 upon 1 plus j omega. If you add these two, so j omega and minus j omega cancel हो जाएंगे. 3 plus 1, you are getting 4 in the numerator. So I am adjusting with 1 by 4 in both of these terms. Is that clear? So this is Fourier transform of Rxy of tau. If you need Rxy of tau, you need to take inverse Fourier transform of these terms. So inverse Fourier transform of 1 upon 3 minus j omega will be y of minus omega. And inverse Fourier transform of 1 upon 1 plus j omega is x of omega. It will be y of minus t and it will be simply x of t. So what is y of minus t? This is our y of t. Y of minus t will be e raised to plus 3t u of t. Let us write the result in terms of tau. So e raised to 3 tau u of tau. What is x of tau? E raised to minus tau u of tau. So this should be my final answer. Comfortable, students? Next. These are the properties I already discussed. Autocorrelation function must be an even function. Autocorrelation function must be maximum at tau equal to 0. And Fourier transform of autocorrelation function must be positive. What is the Fourier transform of e raised to minus a mod of t? 2a upon a square plus omega square. What is the Fourier transform of this function? You need to apply the duality property. See here, e raised to minus a mod of t. Its Fourier transform is 2a upon a square plus omega square. By duality property, omega can be replaced by t. So 2a by a square plus t square. Its Fourier transform will be 2 pi times, in this function, replace t by minus omega. And mod of minus omega is simply omega. Mod of omega. So this is the answer for this function, duality property. This one is also based on duality property. E to the power minus at, इसका Fourier transform क्या होता है? 1 upon a plus j omega. By duality property, omega is replaced by t. So its Fourier transform will be 2 pi, yes, 2 pi. In this function, replace t by minus omega, e to the power a omega. U of minus omega. Comfortable? This one is again a simple one. You can try it. See here. Pi of t minus 1 by 2. Pi means this is the symbol for rect function. This is the symbol for rect function. Okay. So this is actually rect t minus 1 by 2. So students, what they have done, that they have first written rect function. Then they have done time scaling by factor of 1 by 2. So you will get rect t by 2. Then they have done delay operation. So you will get rect t minus 1 by 2. Now coming on to their Fourier transforms. Yesterday we worked on the Fourier transform of rect t. What is the Fourier transform of rect t? It's 2 by omega sine omega by 2. This is the first form, simplest form. I am writing in this form only. Now time is scaling by 1 by 2. So 1 upon 1 by 2 will be 2. Omega will be replaced by omega upon 1 by 2, that is 2 omega. Now simplify this. So 2 to cancel, 2 by omega sine omega. Then delay by 1, it means the previous result will get multiplied by complex exponential term in frequency domain, e raised to minus j1 omega. So this is the Fourier transform of g of t. That is our g of omega. The important thing in this question is, just remember that this pi is the notation for rect function. Now see this question. All of you see here. Here capital X represents what? X of omega. And in this you are putting omega equal to 0. So you are getting capital X of 0. So this is nothing but area under X of t. Do you remember? Yesterday's properties, 12 and 13 number properties. So area under X of t. This is X of t. What is the area under this function? Very simple. Just calculate the area of this entire rectangle. इस पूरे rectangle का area calculate कर लीजिए. And from that area, just subtract the area of this triangle. Correct? Area of this entire rectangle, 4 units and height is 2 units. This width is 4 units and height is 2 units. So 4 2s are 8 minus area of this triangle. Area of triangle is half base. What is the base? Base is 2 units. And what is the height of this triangle? 1 unit. 1 unit. So 7 will be the answer for this first part. Very good, Manoj. Very good. Superb. Second part. In second part, we need area under the spectrum. This integration of x of omega d omega. This is area under spectrum, which is 2 pi times small x of 0. So small x of 0 is 2. So 2 pi times 2, our answer will be 4 pi. Our answer will be 4 pi. Is that very clear? Now see this question. A bit of manipulation required here. I am splitting this 21 into 2 parts. Omega square plus 9 plus 12 divided by omega square plus 9. So omega square plus 9 upon omega square plus 9, that will be 1. And we are getting 12 upon omega square plus 9. Very good. So students, g of omega will be 1. Then in denominator I am having 9 means 3 square plus omega square. So I can write this, split this 12 as 2 times 2 times 3. Correct? Yes, sir. Now inverse Fourier. So inverse Fourier of this will be g of t. Inverse Fourier of 1. Inverse Fourier of 1. बताइए भाई कितना होता है? Yesterday we have seen that it is 2 pi delta omega. And inverse Fourier of this function will be e to the power minus a mod of t. So this is g of t. Tell me fast, you understood or not? Next, see, an LTI system is having impulse response h of t sin 4t upon pi t. Acha. If this is impulse response, what is its frequency response? Sine 80 upon pi t. Sine 80 upon pi t, it's Fourier transform. Yesterday we have put a lot of stress on this. Is rect omega by twice a, that is 8. So characteristic will look like this. This is omega axis. Amplitude will be 1 and width will be 8. So from -4 to +4, amplitude is 1. So this is nothing but a low pass filter. Okay. Now in this low pass filter will be allowing the frequencies in the range from -4 to +4. Now what is the input signal coming to this system? To this system, input signal is x of t. Now we need to find out y of t. Now you tell me which all frequencies are present in this signal. So in this signal, cos square t. Cos square t can be written as 1 minus, not 1 minus, 1 plus cos t by 2 plus sine 60. Okay. So this is the DC component. In this, frequency is omega 1 equal to 2 radian per second, and here frequency is omega 2 equal to 6 radian per second. So input signal is having 0 frequency, 2 radian per second and 6 radian per second. Okay, so these are the frequencies present in the input signal. Comfortable? Yes sir. Out of this will be stopped. 6 will be attenuated by this filter. Why? Because 6 is out of the range of this filter. 6 will be attenuated. 2 and 0 will be passed. 2 and 0 will be passed. It means this first term will be passed to the output. Second term will be stopped. So output will be nothing but cos square t. This cos square t has to be multiplied by gain of this filter, where gain of this filter is 1. Gain of this filter is 1. Generally we say that if 4 is the frequency that is at the boundary, it will be passed by the filter. It will not be attenuated. Then shall we move? Now this is the time to start Z transform. So we will be covering Z transform in the next 1.5 hours. So students, some quality concepts and quality questions are on your way. Please concentrate. I am having a signal x of n, which is discrete time and aperiodic. So I can take its DTFT and Z transform. दो चीजें यहाँ से हो सकती है, DTFT and Z transform. So we are learning here Z transform. So Z transform of this signal x of n. Since this is discrete signal, integration will no more be here. There will be summation sign. Minus infinity to plus infinity. X of n and Z raised to minus n. Okay. And this is nothing but x of z. This result will be x of z. Comfortable with this? Now, this capital Z is the symbol for Z transform operation. X of n is our object signal. X of z is the image signal, you can say. Next. It's quite obvious that if you are calculating the Z transform of x of n, Z transform of x of n is x of z. Inverse Z transform of x of z will be x of n. So students, x of n and x of z, they forms a Z transform pair. When you take Z transform of x of n, you are going to get x of z. Inverse Z transform of x of z will be x of n. Students, always remember that whenever you have mod of z equal to some constant, it means a circle. It means a circle on z plane whose center is at 0, 0 and radius equal to a. Yes, I will just bring the important slides for you. Not investing much time on some derivations and all because that is not required for your gate effect. Now see here, a raised to n, u of n. Since this signal a raised to n is multiplied with u of n, this is a right-sided signal. Right-sided signal, its z transform is z upon z minus a, or you can say 1 upon 1 minus a z inverse. If you just divide the numerator and denominator by z, you will get this answer. Okay. If I multiply this signal by minus sign and make it left-sided, how to make it left-sided? In u of n, n will be replaced by u of minus n minus 1. So its z transform will be, mathematically it will be same as that of the first result, that is z upon z minus a, or 1 upon 1 minus az inverse. What makes a difference here? That is their ROC. So ROC for the first part is mod z. Since it is right sided causal signal, its ROC will be mod z greater than a, and for the second case ROC will be mod z less than a. And you know, mod z equal to a represents a circle of radius a. So mod z greater than a represents the region outside this circle, and mod z less than a represents the region inside the circle. Okay, this one is causal, right sided. This one is anti-causal, that is left sided. Comfortable? Left sided, right sided. Okay, yes sir. Good morning Chinmay, how are you? These are the points related with ROC. Just go through it. See this question. X of n is 1 by 3 raised to n u of n minus 1 by 2 raised to n u of minus n minus 1. Students, this one is right sided term and this one is left sided term, correct? Yes sir. Their z transform is x of z. For the first term, z transform is z upon z minus a. For the second term is left sided. Left sided term is accompanied with a minus sign. Okay. So if left sided term is having a minus sign, then its z transform is positive. See, if the left sided term is having a minus sign, then its z transform is positive. If this minus sign is missing here, then this minus sign will be reflecting in the right hand side. So currently in this question, we are having a minus sign here. So its z transform will be positive. भाई समझ में आया आपको? If you have a left sided term, anti-causal term, accompanied with a minus sign, then its z transform will be positive. Z upon z minus a, where a is 1 by 2. Correct? Yes, sir. Now, for the first part, let us say the ROC for the right sided term is mod z greater than a, outside the circle of radius 1 by 3. And for the second part, individually, ROC will be mod z less than 1 by 2. That is for left sided term. So, we have obtained the z transform, but we want the net ROC. So, net ROC will be R, which is intersection of R1 and R2. So, intersection of R1 and R2, mod z greater than 1 by 3 and mod z less than 1 by 2. Here. This is real axis, this is imaginary axis. Now you tell me, mod z equal to 1 by 3 will be a circle of radius 1 by 3. Then we have mod z equal to 1 by 2. Mod z equal to mod z equal to 1 by 2. So this is a circle of radius 1 by 2. Now you see here that R1 is the region outside 1 by 3. Not visible. R1 is the region outside 1 by 3 and R2 is the region inside 1 by 2. So The net ROC will be the intersection, that is the common region of these two. Following? See here. Outside 1 by 3 and inside 1 by 2. So the common region will be between these two circles. So net ROC will be the region between these two circles. This region is called as annular strip or annular ring. Okay. So net ROC will be mod Z lying between 1 by 3 to 1 by 2. Correct? Yes. Now students, listen carefully. If the net ROC is lying outside the outermost circle, then your signal or system, whatever you are talking about, is causal. If the net ROC is inside the innermost circle, then your net system or signal anti-causal signal. But if the ROC is lying between two consecutive poles, two consecutive circles, दो लगातार circles annular strip के बीच में आ रहा है, if you are having in ROC as the annular strip, then it will be both sided non-causal system or signal. Okay, since x of t is a signal, x of n is a signal here, then x of n is representing a both sided non-causal signal. So they are asking whether this is causal or not. So answer should be no, it is not causal. It is both sided non-causal. Can I have everyone's response on this? No. Also find whether x of n is absolutely integrable or not. Now listen here. Where is your ROC? The ROC is between 1 by 2 to 1 by 3. This is the ROC, correct? Haji. Is this ROC including unit circle? Where is the unit circle? Arey bhai, unit circle means what? Unit circle means a circle of radius 1. So circle of radius 1 will be somewhere outside this, na? This will be unit circle. So is your ROC covering this unit circle in it? Is this ROC covering this unit circle? No. So if unit circle is not present in the shaded region, if this unit circle is not present in the shaded region, then we say that ROC does not include unit circle. If ROC does not include unit circle, then it is not absolutely summable. X of n is not absolutely summable. Why? Because ROC does not include unit circle. If ROC includes unit circle, then it is absolutely summable. Okay. So absolute summable means stable system, not absolute summable means unstable system. So if this x of n represents the impulse response of a system, then it will be representing an unstable system because ROC does not include unit circle. Okay. Comfortable with this? So response. Now see here. Now students, concentrate here. Mod function. Mod function is n for positive and minus n when n is negative. Okay. So concentrate here. 1 by 3 raised to mod n. 1 by 3 raised to mod n. So it has got two values. 1 by 3, Anji, 1 by 3 raised to positive n when n is positive, and 1 by 3 raised to minus n when n is negative. Now apply your entire energy here. 1 by 3 raised to minus n. 1 by 3 raised to minus n. This 1 by 3 can be replaced by 3 to the power minus 1. इस 1 by 3 को लिख सकते हैं 3 की पावर minus 1. and then it is raised to the power minus n. This is actually equal to 3 raised to n. Okay, so 1 by 3 raised to minus n is 3 raised to n. So bachcha log, 1 by 3 raised to mod n can be splitted into two parts. 1 by 3 raised to n when n is positive. N is positive means it is multiplied by u of n. Okay, 1 by 3 raised to minus n means 3 raised to n, and this will be available when n is negative. So n is negative means n is not n less than 0 does not include 0, huh? So it will start from minus 1. So u of minus n minus 1. When I write u of minus n minus 1, it is available from minus 1 to minus infinity. It is not available at 0. Remember this. So how many of you understood the expansion of 1 by 3 raised to mod n? किसको समझ में आया expansion of 1 by 3 raised to mod n? So 1 by 3 raised to n u of n. Then we have minus, okay, plus sign, 3 raised to n u of minus n minus 1. And the last term is minus 1 by 2 raised to n u of n. So let us find the z transform for this. So x of z. So 1 by 3 raised to n u of n. What is its z transform? Its z transform will be z upon z minus 1 by 3. Let us write the individual ROC mod z greater than 1 by 3. Then this second term is a left-sided term. For a left-sided term, in time domain, if minus sign is missing, that minus sign will be provided to the z transform, will be applied to the z transform. So its z transform will be minus z upon z minus 3. Comfortable? And the net ROC will be R2 mod z. Left-sided term means mod z less than 3. Last term minus z upon z minus a, z upon z minus a, and R3. What is the R3? Mod z right sided, so greater than 1 by 2. So students, we need to find out the ROC on the z plane. Okay, so net ROC will be R1 intersection R2 intersection R3. So we have got three circles, 1 by 3 radius, 1 by 2 radius, and 3 radius. This is our z plane. Comfortable with this? This circle is having radius 1 by 3. This circle is having radius 1 by 2. This circle is having radius. Okay. Yes sir. अब क्या करें? ध्यान देना. What is R1? R1 is the region. R1 is the region outside 1 by 3. R1 is the region outside 1 by 3. So Ravi is revealing that admit cards have been released. That's a great news. So 8 admit cards have been released as per the information by Ravi, and our team will also be bringing one official announcement for that also. Ravi. So mod z greater than 1 by 3. Mod z greater than 1 by 3. So this is the region. Okay. Then mod z less than 3. Mod z less than 3 means 3 से अंदर आना है. Inside 3. So this is the region. Okay. Then mod z greater than 1 by 2 means outside 1 by 2. This circle, middle circle is 1 by 2 radius. Now, what is the common region? इन तीनों में कॉमन कौन सा है? दैट इज योर रीजन ऑफ कन्वर्जेंस, कॉमन रीजन. So common region is obviously this portion. Comfortable? So students, net ROC will be mod z lying between circles of radius 1 by 2 and 3. Comfortable with this? Now this region covers unit circle. इस region में unit circle आएगा. See, from 1 by 2 to 3, when you proceed from 1 by 2 to 3, definitely 1 will be coming inside this. 1 will be contained in this interval. So unit circle is present in this ROC. So this is absolutely summable. Absolutely summable means stable. Okay. So is this signal causal or not? No, this is both sided non-causal. Still it is both sided non-causal. So both sided non-causal, but the system is stable this time. Absolutely summable. Absolutely summable. Come on, respond कीजिए. Next. So now the properties of Z transform. So first one is the linearity property. You would be well aware of this. X1n is having Z transform X1Z, X2n is having Z transform X2Z. So a linear combination of X1 and X2 will give you Z transform A1 X1Z plus A2 X2Z. Okay. Already we utilized this one. So just go through this question. Similar question, but in this question you will find a minus sign here. So just to avoid this confusion, I'm just writing the Z transform. So Z transform of this will be Z upon Z minus A. So Z minus of minus 1 by 9 will be plus 1 by 9. See, this is left sided term, and this left sided term is multiplied with a minus sign. So our Z transform will be positive. Z upon Z upon Z, Z plus 1 by 3. Correct? Yes, sir. Z upon Z plus 1 by 3. Okay. What can be done? This will be the Z transform. What is the net ROC? First one, R1. Mod Z, R1. What is this? What is the ROC for this first part? पहले part के लिए ROC क्या होगा? Mod Z, this is right sided. Mod Z greater than, see, don't take the negative sign because this is radius of the circle. So mod Z greater than 1 by 9. This is the first case. Similar is mod Z greater than 1 by 3. Okay. So students, net ROC will be lying between 1 by 9 and 1 by 3. So this is not greater than 1 by 3. This is less than 1 by 3. Okay. mod z greater than 1 by 9 and mod z less than 1 by 3. So this is the net ROC. Find whether signal is causal or not. This is not causal. This is both sided non-causal. Okay. Also find whether x of n is absolutely integrable or not. So no, this is not including unit circle. So this is not absolutely summable. Not absolutely summable. Comfortable with this? This you can try by your own. Here in question of shifted signal that has negative sign. I'm not getting your question, Ravi. See, whatever we have learned for a signal, the same is applicable for the system also. But when we say that h of n is representing a system, h of n is actually its impulse response. Now see, if h of n is the impulse response of a discrete time system and its z transform h of z is given as, okay, h of z is given, see, 0.2 raised to n u of n, its z transform is z upon z minus 0.2, and if it is minus 0.2 raised to n, yes, Ravi, see here, u of minus n minus 1, then also z transform will be z upon z minus 0.2. Now to decide which one is our answer, you need to go with the ROC. So here for this first case, ROC is mod z greater than 0.2. For the second case, ROC is mod z less than 0.2. Okay? Yes, sir. You can just go through this. Mod z greater than 0.2 and mod z less than. Okay. So here ROC is mod z less than 0.2. Mod z less than 0.2. So this will be our answer. This is our h of n. Comfortable? So both ways it is positive, but depending on the ROC, you need to select the correct h of n. Now see this. X of z is given. ROC of x of z includes unit circle, then x of 0. Very nice question. See, so here pole value, this is pole, mod z equal to 2 is the pole. Plot this pole here. Now what they are saying that ROC includes unit circle. So this is the pole. So ROC has two options, either inside this or outside this. So under what situation it will include unit circle? When the ROC is inside this. So this is the ROC. If this is the ROC, then you need to write an anti-causal system. If this is the ROC, means ROC is mod z less than 2. So inverse z transform of 0.5 upon 1 minus 2z inverse. So 0.5 is out. 0.5 is out. So it will be left-sided response. Ravi, left-sided response minus 2 raised to n u of minus n minus 1. Now what you want? Small x of 0. Actually, this is your x of n. Na? We want small x of 0. Can you tell me what is small x of 0? Now what is the answer for this? Tell me. I have written x of n for you. Just give me x of 0. Students, listen carefully. Minus 2 raised to n. Minus 2 raised to n u of minus n minus 1. This u of minus n minus 1 is available from minus infinity to minus 1 only. It is not available at 0. So answer will be 0 for this. X of 0 is not available. Very nice question. Very conceptual question. It's not tricky but conceptual. Time shifting property. If x of n is having z transform x of z, then z transform of x of n minus k will be z raised to minus k x of z. Time reversal. If there is a folding in time domain, then you need to take the reciprocal of z. So x of minus n's z transform will be x of 1 by z. This one is important. If z transform of x of n is x of z and you are multiplying by n in x of n, then in the z domain you need to take differentiation minus z d by dz x of z. Okay. So n x of n minus z d by dz x of z. Now see here. X of n is having z transform x of z. When you are multiplying by a raised to n, then there is a scaling in z domain. It will become x of z by a. That's it. Time differencing property. Since x of n is a discrete signal, in discrete time signal for discrete time functions you cannot have differentiation. So a similar analogous operation for discrete domain is this differencing operation. So current sample minus previous sample, like this. This operation is called as differencing. So x of n z transform is x of z, and by time shifting property x of n minus 1 z transform is z raised to minus 1 x of z. So if you take x of z common, so you will get 1 minus z inverse as the coefficient. Comfortable? In time accumulation property, just opposite. When you are taking the summation, x of z will be divided by 1 minus z inverse. X of z will be divided by 1 minus z inverse. Convolution property is much familiar to all of you. When you are convolving in time domain, it is equivalent to multiplication in z domain. Initial value theorem. X of n is having z transform x of z. So x of 0 plus, that is we are focusing on the initial value of x of n. This is limit z tending to infinity 1 minus z inverse x of z. Okay, please concentrate here. Limit z tending to infinity. 1 minus z inverse means 1 upon 1 by z. One upon infinity is 0. So this will be x of z. Okay. This can also be seen as the initial value theorem's statement. Next, final value theorem. In final value theorem, we are focusing on the final value x of infinite. So limit z tending to 1 is 1 minus z inverse x of z. That's it. You can write this as z minus 1 upon z x of z. You can put z equal to 1, the denominator. That is partial application of the limits. This can also be seen as the statement for final value. Z transform of delta n is 1. Fourier transform of delta t is also 1. Laplace transform of delta t is also 1. So this 1 will be common. dtft of delta n is also 1. Now, by first shifting property, if you have shifted this delta n by some amount k, so delta n minus k, of course duality is valid for Fourier transform. So delta n minus k, we don't require in case of Z transform, Ravi. Delta n minus k, Z transform is Z raised to minus k. Remember this one is very, very important. Delta n minus k, Z transform is Z raised to u of n Z transform. Obviously, a raised to n u of n. In that formula, if you put a equal to 1, you will get Z transform of u of n. Now, how to approach this kind of question? See, there are two approaches. We'll follow any one of them. We know that a raised to n u of n, mathematically its Z transform is Z upon Z minus a. Now, time shifting properties, n is replaced by n minus 1. So in the right side, on the right side you need to multiply it by Z raised to minus 1. So 1 upon Z minus a is the formula. But at the same time, this is a raised to n upon a, right, into u of n minus 1. So a raised to n u of n minus 1, its Z transform will be a is cross multiplied to the other side, a upon Z minus a. Now see this one. X of n is a raised to n u of n minus 2. How to approach with this? See, I am now showing you another approach. U of n Z transform is Z upon Z minus 1. Now, apply time shifting property. U of n minus 2 Z transform. So, U of n minus 2 Z transform is Z raised to minus 2 Z upon Z minus 1. This is Z raised to minus 1 upon Z minus 1. Now, this is multiplied by a raised to n. A raised to n, whenever you are multiplying by a raised to n, there will be scaling in Z domain. Z will be replaced by Z by a. So this will be a square upon Z into Z minus a. Okay? Yes, sir. See, this one is a direct formula. How we applied that? It's a derivation. I'll just give you that idea. A raised to n u of n Z transform is first formula Z upon Z minus a. And it is multiplied by n. So it is differentiation in Z domain. Minus Z d by dz of the previous result. So you just remember this as az upon Z minus a whole square. Why this one is important? If you put a equal to 1 both sides, you will get n u of n, which is your discrete time ramp signal. Z transform is Z upon Z minus 1 square. Now, for this one, you need to differentiate 2 times, and this will be az into Z plus a upon Z minus a whole cube. Chetan Chauhan, very good, thank you. az into z plus a upon z minus a whole cube. So students, in this particular signal, if you put a equal to 1, you will get n square u of n. This will be discrete time ramp signal, discrete time parabolic signal. Its z transform will be z into z plus 1 upon z minus 1 whole cube. Let's solve this question. This one is a good one. So first of all, see, 5 raised to minus n u of minus n minus 1. This is actually 1 by 5 raised to n u of minus n minus 1. So its z transform will be minus z upon z minus a. Correct? Great. We obtained the z transform of 5 raised to minus n u of minus n minus 1. In this, if we delay by say 3 units, so delay by 3 units means minus n plus 3 n minus 3 minus 1. What you will get? Minus n plus 3 minus 1 will be plus 2. That is our requirement. So we need to delay this by 3 units. So delay this by 3 units means 1 by 5 raised to n minus 3 u of minus n minus 3 minus 1. And when you delay by 3 units, you need to multiply by z raised to minus 3 on the right hand side. Perfect. Now see here, 1 by 5, that is 5 raised to minus n, 5 raised to, this is 1 by 5 raised to 1 by 5 raised to n means 5 raised to minus n, and 1 by 5 raised to minus 3, that is 5 raised to 3. Correct? Is that correct? Then u of minus n plus 2 minus z raised to minus 2 upon 5z minus 1 upon 5. So this 5 is brought to the numerator. So 5 raised to minus n u of minus n plus 2, divide by 5 cube both sides. So 1 5 will be cancelled, 25 will appear here, 5z minus 1, and this z raised to minus 2 is also brought to the denominator. This is the answer. It needs a proper flow, proper sequence of steps to solve Z transform questions. Okay. You can try this question. Similar question. This one also is simpler. Now, relation between S plane and Z plane. Z equal to e raised to st. Okay. Here Z stands for r e raised to j omega. This is the symbol. And S stands for sigma plus j omega. Okay. So students, what we want? This relation gives us the mapping between S plane and Z plane. Now see here. What we expect that j omega axis on S plane should be mapped on the unit circle on the Z plane. This we are expecting. Okay, and this can be achieved with this conversion rule. Okay, left half S plane should be mapped inside this unit circle, and right half S plane should be mapped outside the unit circle. Okay, This is what we are expecting. See this example. G of n, x of n minus x of n minus 1. Okay. So x of n is 1 from 0 to 5. This is our x of n. This is our x of n. We want x of n minus 1. So x of n minus 1 is its delayed replica. This is x of n minus 1. So when you take the difference, that is x of n minus x of n minus 1. So you will get 1 minus 0, that is 1. Then you will get 1 minus 1, 0, then 0, 0. How many zeros you will get? 1, 2, 3, 4, 5. 5 zeros. And sixth sample is absent in the first part and sixth sample is present in the second part. So 0 minus 1 will be minus 1. What we want? We want g of z. So this g of z is, Anji, before that I'll just represent this in the form of impulse. Yes, sir. So this will be delta n and then minus this sample is present at n equal to 6. So minus 1 delta n minus 6, correct? Yes, sir. So its z transform will be delta n z transform will be 1 and delta n minus 6 z transform will be z raised to minus 6. Okay, sir. So 1 minus 1 upon z raised to 6. So except z equal to 0, entire z plane is the ROC. When you put z equal to 0, this will become infinite. So z equal to 0 is not the part of ROC. Except z equal to 0, entire z plane will be the ROC. Next. Actually, everyone should answer this question. The region of convergence of the z transform of unit step function. Region of convergence of the z transform of unit step function. Come on. Unit step function. Z transform is z upon z minus 1. ROC will be mod z greater than 1. Comfortable? Option A is the correct answer. Now see this one. Please go through this question. All of you must go through this question. A sequence x of n with the z transform x of z, z raised to 4 plus z square plus 2z plus 2 minus 3z to the power minus 4 is applied as an input to a linear time invariant system with impulse response h of n equal to 2 delta n minus 3. So students, what you need to do? You need to take its z transform h of z. It is 2 times z raised to minus 3. You need to multiply x of z with h of z. so that you will get y of z. So 2z raised to minus 3 into z raised to 4. That is 2z. Then 2z raised to minus 3 into z square. 2z raised to minus 1. Then 2 into 2, 4. Z raised to minus 2. Then 2 to the 4. Z raised to minus 3. Then 2 into 3, 6. So minus 6 z raised to minus 7. So clearly we can say that y of n, see, z raised to 1's coefficient is 2. So this is the sample at n equal to minus 1. At n equal to 0, we have 0. Then at n equal to 1, we have 2. N equal to 3, n equal to 2, we have 4. Then 4. At n equal to 4, 5, 6, no samples. At n equal to 7, we have minus 6. So they are asking the signal at n equal to 4. That is 0. Comfortable? Our signal y of n is not available at n equal to 4. So this will be 0. Linear phase filter. See here. If we are having an h of n, this h of n is even symmetric about this value alpha. Yes or no? This h of n is even symmetric about this value alpha. Let us say this alpha is 5, 6, 7, then 4, then 3. So 3, 2, 1, 2, 3. Can we say that h of n is even symmetric about 5? Yes, sir. See here. Students, can we say that this h of n, this second one, is odd symmetric about this value, this dot value? Yes, Ravi will do that. Definitely. Now see, concentrate. This h of n is even symmetric about, h of n is even symmetric about 5, and this h of n is odd symmetric about, tell me that point, 1. So this value is alpha. If your impulse response of the filter is either even symmetric or odd symmetric about a particular value alpha, then that h of n represents a linear phase filter, and in that case its phase response, that is theta omega, will be minus alpha times omega. Are you following? For a linear phase filter, phase response is linear and it is given by theta omega equal to minus alpha omega. What is this alpha? alpha is that value about which the impulse response is either even symmetric or odd symmetric. Done with this? For a minimum phase filter means all the poles and zeros must lie inside the unit circle. For a minimum phase filter, all the poles and zeros must lie inside the unit circle. For a minimum phase filter, all the poles and zeros must lie inside the unit circle. All pass filter. For all pass filter, poles and zeros are conjugate reciprocal of each other. Poles and zeros are conjugate reciprocal of each other. Maximum phase filter. For maximum phase filter, all the zeros lies outside the unit circle. Yes, Chinmay. Both in case of linear phase filter, I repeat, in case of linear phase filter, if impulse response h of n is either even symmetric or odd symmetric about a particular value alpha, then that will represent a linear phase filter, and its phase response will be given by minus alpha times omega. Got it? Non-minimum phase or mixed phase filter. Some of the zeros lies inside the unit circle, some of the zeros lies outside the unit. Now, this particular question is an important one. I hope all will concentrate towards this question. I'll just hide myself so that you would be able to see the entire question. I believe this question is one of the best question in Z transforms. Obviously it will take some time to complete, but definitely this will be giving you some of the best of the concepts. The following is known about a discrete time LTI system with input x of n and output y of n. They have provided you certain informations regarding a discrete time system. If input is minus 2 raised to n, then output is 0. If input is 1 by 2 raised to n u of n, then output is this equation. Okay. A is a constant. We need to find the value of A and we need to find out the response y of n. See. I go back. See here. This is our discrete time LTI system whose impulse response is h of n. Concentrate. If the input signal is having this pattern, some constant to the power n. See, this is an exponent function, right? So it is neither multiplied by u of n or it is neither nor multiplied by u of minus n minus 1. Means it is both sided signal, okay? Exponent. And h of n's z transform, that is system function, is h of z. So for such type of input, output is simply input multiplied by h of z naught. Understood? Output is input multiplied by h of z naught. So this type of inputs are called as eigen-function. Okay, and when you put this z naught in this h of z, got this h of z naught, this is called as eigenvalue. Now what they have given, that x of n is minus 2 raised to n and output is 0. Acha ji. So output for this input minus 2 raised to n, you tell me, it is output will be input times, output will be z naught raised to n times h of z naught. So z naught is minus 2. So minus 2 raised to n multiplied by h of minus 2. Comfortable? This is the output. But they have given that the output is 0. Okay. Now the quantity of these two, the product of these two terms is 0. So either the first term or the second term or both will be 0. So both of them cannot be 0. So this possibility is striked out. Minus 2 raised to n, ये भी 0 नहीं हो सकता because this is the input signal. This cannot be 0. So this is giving me a beautiful conclusion that h of minus 2 is 0. And I will be utilizing this in other steps ahead of this. Now you just tell me, have you all got the concept of this eigen-function type of input? I need your response. I need your response. Have you all got the concept of this eigen-function type of input? Now, when input signal, when input signal is Ravi, when input signal is of this pattern z naught raised to n, then output signal is simply input signal multiplied by h of z naught. That's it. X of n is given as minus 2 raised to n, so z naught is minus 2. So minus 2 raised to n h of minus 2, but the corresponding output is 0. So this is giving us the conclusion h of minus 2 equal to 0. Now see the second part. In the second part, input signal is 1 by 2 raised to n u of n. This is not eigen-function type of input. Remember this. X of n is 1 by 2 raised to n u of n. Correct? So its z transform will be z upon z minus a. Very good. Anji. And what they mentioned, they have also given you the output. So output is y of n equal to delta n plus a times 1 by 4 raised to n u of n. So its z transform will be y of z. Input z transform is x of z, output z transform is y of z. Delta n z transform is 1, then a constant 1 by 4 raised to n u of n. Its z transform is z minus 1 by 4. Correct? Concentrate here. H of z is y of z upon x of z. 1 plus 1 plus 4 is taken as the LCM. So 4az upon 4z minus 1. This is numerator upon denominator. Denominator. Just simplify this 2z upon 2z minus 1. Great. So we already have h of minus 2, which is 0. देखो भाई, h of minus 2 is, so you just put z equal to minus 2 here. So 1 plus z is minus 2, right? So 4 into minus 2 is minus 8a. 4 into minus 2 is minus 8, minus 1 is minus 9. अरे भाई फिर से देखिए, 4a into minus 2 minus 8a. Very good. 4 into minus 2 is minus 8, minus 1 is minus 9, so this will become plus 9. Upon what? 2 into minus 2 will be minus 4. Upon 2 into minus 2 is minus 4. Minus 4 minus 1 is minus 5. Correct. And this is nothing but 0. So this denominator is cross multiplied to 0. Yes sir. So बच्चा लोग 8a by 9 equal to minus 1. So a will be minus 9 by 8. We have obtained this value of a. So first question was, they were asking you the value of a only. Second question, find the response y of n if the input is x of n equal to 1. So after getting the value of a, you just put this value here in this h of z. Get the answer for h of z, final answer for h of z. So h of z will be value of a is minus 9 by 8. So 1 plus 4az. करेक्ट है नहीं? 1 plus 4az upon 4z minus 1 upon नीचे कितना है 2z upon 2z minus 1. This is h of z. We obtained the value of h of z. What we want? We want output when input is 1. 1 means 1 raised to n. Again it is eigenfunction type of input. So our answer will be z naught raised to n and h of z naught, that is h of 1. So 1 raised to 1 is 1. H of 1 will be our answer. So put everywhere z equal to 1. So 1 minus 4 is cancelled with this 8. So minus 9 by 2, that is already 1, divided by 4z minus 1. So 4 minus 1 is 3 upon 2 minus 1, that is 2. Akansha, just give me 1 second. I'll just calculate. Good morning, Ila. Yes, Akansha. Can anyone post my Telegram channel's link here? Raghuram, are you there? Just a moment. Yes. So 9 is cancelled with this 3 by 2 upon 2. How much it is? Minus 1 by 2 upon 2, minus 1 by 4. Just check. I hope you would not have done any calculation mistake here. Okay. Akansha, Chinmay Roy is saying a minus 1 by 4. Yes, minus 1 by 4, correct. Thank you, Raghuram. Akansha, whenever we have some constant raised to the power n, then this type of input is referred as eigenfunction type of input. So in the very first statement, minus 2 raised to n, it is not multiplied with u of n. So this is simply eigenfunction type of input. And in the last case where we want to find out the output for x of n equal to 1. So 1 is not multiplied with u of n. So we are considering this 1 as 1 raised to n eigenfunction type of input. Just check the calculations once. Everything is all fine regarding the concepts. See this is a simple one. Impulse response of a discrete time system is this one. They are asking for h of z. Very simple. This will be z upon z minus 5, right? And ROC will be mod z less than 5. So when ROC is mod z less than 5, it will include unit circle. System is stable. So z upon z minus 5 and system is stable. Option B is the correct answer. Next. The Z transform of a system is h of z, z upon z minus 0.2. If the ROC is mod z less than 0.2, then the impulse response of the system. चलिए इसको देखते हैं. They are saying that ROC is mod z less than 0.2. It means it is left sided. It is left sided. So h of n will be minus 0.2 raised to n of minus n minus 1. But a minus sign will be there in our answer because that minus sign is absent in h of z. So option D will be the correct answer. Yes, Manoj Kumar, very good, beta, superb. I request all of you to hit the like button if you have not done so. See this question. Some of the beautiful questions from Z transform. A causal, very important word, causal LTI system is described by this difference equation. They also mentioned that it is stable. This is stable. We need to find out the values of alpha and beta. So first of all, we'll write this equation Z transform. चलिए इसका Z transform लिखते हैं. So 2 times y of n Z transform is y of z alpha. Y of n minus 2, its Z transform is z raised to minus 2 y of z minus 2x of z and plus z raised to minus 1 x of z. Now what to do? You can take this y of z term to the left hand side. So 2 minus alpha z raised to minus 2 y of z. So x of z is taken common here. Beta z inverse minus 2. So what is y of z upon x of z? This is h of z. Correct? So poles of h of z. Got it? So poles are root of alpha by 2. Poles are root of alpha by, okay. What we want? Alpha in, na? Hmm. Do we have any dependency for a system to be stable on the zeros? Not at all. Only it depends on the poles. So this term, pole value, it must, see, system is causal, so ROC will be right sided. ROC will be right sided and it must include unit circle. This is the ROC. It means root of alpha by 2 should be less than 1. So if you square it, you will get alpha by 2 less than 1. So alpha should be less than 2, or you can say mod of alpha should be less than 2. Mod of alpha should be less than 2 and any value of beta. Sir, once again explain this. See here. they have given that, okay, we obtained that the pole value is mod z equal to alpha by 2, put alpha by 2. So this is the pole value. Now they are mentioning that the system is causal. Since the system is causal, ROC will be outside this. They are also saying that system is stable. If system is stable, this ROC must include unit circle. This ROC must include unit circle. It means unit circle will be somewhere here in the ROC. So this radius is 1 and inner radius is root alpha by 2. So we can clearly say that root alpha by 2 should be less than 1. On squaring both sides, we are getting alpha by 2 less than 1. So alpha less than 2, or simply we can say mod alpha less than 2. So mod alpha less than 2 and no dependency on beta. Mod alpha less than 2 and no dependency on beta. So option C should be the correct answer. Option C should be the correct answer. Okay. This will be the correct answer. Option C. Mod alpha less than 2, any value of beta. रिस्पॉन्ड तो कर दीजिए भाई. This you can try. Already we have done similar questions. So many questions. See this. Consider the Z transform. This is X of Z. The inverse Z transform X of N. Very, very simple. Okay, Payash. So X of N will be 5 times delta N plus 2, 4 times delta N minus 1, and 3 times delta N. This color is not visible, sir. So 5 times delta N plus 2, 3 times delta N, and 4 times delta N minus 1. Option A is the correct answer. Now see this question. Two discrete time systems with H1 and H2 are connected in cascade. See, H1 and H2, they are connected in cascade. X is the input, Y is the output. So, net impulse response. So, H1Z will be Z raised to minus 1. H2Z will be Z raised to minus 2. So, net H of Z will be product of these two, that is Z raised to minus 3. So, H of N will be simply delta N minus 3. So we can say that delta n minus 3 will be the correct answer. Next question. See this. I need to hide myself so that you can see the entire question. See here. For this particular question, by seeing the options, we can easily say that 1 by 2 and 1 by 4 are the poles for this H of Z. Okay. So if you draw an ROC, inner circle is having radius 1 by 4 and outer circle is having radius 1 by, inner circle is having radius 1 by 4 and outer circle is having radius 1 by 2. Now see here, when you are outside this outer circle, when you are outside this outer circle, that is mod z greater than 1 by 2, then your system is in ROC will be including unit circle, so stable as well as causal. For the innermost circle, region inside the innermost circle, it is anti-causal and unstable. And here, between the annular strip, it is both-sided non-causal and unstable. Now what they are expecting? Statement S1. क्या है statement S1? देखिए, the system is stable and causal for mod z greater than 1 by 2. So this statement is correct. Stable and causal for mod z greater than 1 by 2. The system is stable but not causal for mod z less than 1 by 4. System is stable but not causal. No, this is wrong. The system is neither stable nor causal for mod z between 1 by 4 and 1 by 2. Neither stable nor causal. Yes, this is also correct. So statement S1 and S3 are correct. Option C is the correct answer. Okay. You can see this question as well. Prakash, obviously to get the feel of a subject, you need to be practicing more. So most probably this will be the last question from my side in Z transform, and then your favorite Ashu Jangda sir will be joining you. Okay. Yes, and I will be providing you the PDFs in my corresponding Telegram channel, Electronics by Ankit Joshi. Chaliye. Two systems H1Z and H2Z are connected in cascade as shown below. The overall output y of n is same as the input with a 1 unit delay. Just go through the wordings. Overall output y of n is same as the input with a 1 unit delay. So this is the equation. Now taking z transform both sides, you will get y of z equal to z raised to minus 1 x of z. So when you take the ratio of y of z to x of z, you will get h of z, that is system function or transfer function, that is z raised to minus 1. Okay. We want h2z. So h1z into h2z is h of z. So h1z into h2z, this will be h of z. So h2z will be h of z upon h1z. h1z is this one. So this will appear in denominator. So 1 minus 0.4 z inverse upon this quantity. So be appearing in numerator. Z inverse 1 minus 0.6 z inverse 1 minus 0.4 z inverse. Option B is the correct answer. Yes, let me check with Ashu sir. He is available right now. All set. Okay, so students, let's proceed. One more question for you. Just go through this. The input-output relationship of a causal stable LTI system is shown. So let us just find out this h of z from here. So y of n z transform is y of z alpha times y of n minus 1 z transform is z raised to minus 1 y of z and beta times x of z. So students, you can work out h of z from here. That will be beta upon 1 minus alpha z inverse. So students, h of n, that is inverse z transform from here, will be beta times alpha raised to n, and since this is causal, yes, they mentioned somewhere it is causal, yes. So alpha raised to n u of n. So we have obtained the value of h of n. Now they have given you this, relationship that summation of h of n is 2. So we can take beta out. So beta is out. Since summation is from n equal to 0 to infinity, alpha raised to n, u of n will be 1 in this case. So this will be 2. Open this summation. Alpha raised to 0 is 1, then alpha square. So it will be an infinite GP. Sum of infinite terms of a GP. Sum of infinite terms of a GP means first term upon 1 minus common ratio. So बच्चा लोग, beta equal to 2 minus 2 alpha. I got the message. Ashu sir is ready. We'll just work out this here. Beta will be 2 minus 2 alpha. So 2 alpha will be 2 minus beta. So ultimately alpha will be 1 minus beta upon 2. Just go through the answer. I guess option A is the correct answer. The relationship between alpha and beta is alpha equal to 1 minus beta by 2. So students, that's all from my side in this session. And now your favorite Ashu sir will be joining. So students, if you have not liked this session, I request all of you to hit the like button. Okay. And I hope you would have enjoyed this session till now. And Ashu sir will be making this session more knowledgeable and more enjoyable for you. So just permit me to move ahead, go away, and I will be stopping from my end. So thank you students. Wish you all the best for your exam. Love you all. Take care. Stay happy. Stay safe. Jai Hind.
Hello everyone. So good afternoon, and tell me, is audio video clear? I think audio video is clear. So wait a minute. Yes. नमस्कार सब दोस्तों को. तो आई होप आपकी तैयारी अच्छी चल रही है, एंड आई होप आप एकदम मस्त चल रहे हैं, तैयारी एकदम बढ़िया चल रही है. सो इन टुडे सेशन विल डिस्कस अबाउट LTI सिस्टम, नॉन LTI सिस्टम, especially the non LTI part, because non LTI part is a bit difficult for the students. And if you look at the past 2-3 years, then there are some questions on non LTI also. They started asking questions on non LTI systems also, so that's why I'll cover the non LTI part also. So we'll study that, and then we'll cover the Fourier series part, continuous and discrete time Fourier series. Okay, so better you share this session to all the channels where you are connected, so that everybody can join. And don't forget to like this session, because now the likes are 45. I want to make the century of the likes. Okay, so keep liking the session, and let's start. So let's start the session. This is my introduction, and I teach almost every subject. Right now it's time for the signal and system. Okay, so yesterday's class also I have taken on signal system, and in yesterday's class I was discussing about basics of the signal and system. Okay, so this is Maha marathon series which is going on, and I hope you are enjoying the Maha marathon series. And let me tell you guys, the core part has also started. So you can start the core part also, like EDC in for communication engineering, electronics and communication, and power system for electrical engineering. Okay, after power system we'll start with machine and power electronics. Okay, so there is one more session, how to ace gate 2024 with college and job. So this session will be taken by Dheeraj Sardana sir, and it will be on 10th of January at 7:30 p.m. So you can recommend this session to your juniors, to your friends who are preparing for 2024. Okay, and general aptitude session will start soon, and Rakesh Taleja sir will take this session. So stay connected, and I hope you'll get 15 marks out of 15 in general aptitude with Rakesh sir. And let me tell you guys, one more important session for mathematics, because mathematics is very vast and very important for the students, and it's easy to score. Okay, so mathematics session is also going to start, and the date will be announced very soon, and this session will be taken by Rakesh sir and Ankit sir. Okay, so they will take this session, so I hope you'll enjoy this session also. Now it's time for the test series, guys. So better you join the test series so that you can check your preparation, check your speed, accuracy, and check your mistakes so that you can rectify the mistakes. Okay, so you have to join the test series, and you can join the BYJU'S exam prep test series. Okay, BYJU'S test series is again according to the GATE syllabus, and the interface is again exactly like the GATE exam. Okay, so in this test series you will get many tests and the mock tests, subject wise tests, so you can give those tests, and you can analyze your preparation. Okay, so let's start the session, but before starting, please subscribe if you have not subscribed this channel, and like this session if you haven't liked it, and press the bell icon so that you get the notification whenever this session will be live. Okay, so let's start, guys. So in today's session I'm going to start with the systems. In previous class I have started with the signal, and I have covered the signal part. Now let's take a review of systems. Now, what is system? System is something which takes input and which gives you output. Which takes input and which give you output. We call it system. Okay, we call it system. This is my system. It's like communication system or power system. Okay, so it takes you give the input at one place and you take the output at the other place. We call it system. Now it can be of many types. We have categorized this system in linear, non-linear, linear and non-linear. Number 2, time variant and time invariant. Number 3, causal and non-causal. Number 4, static and dynamic. We also call it memoryless and with memory system. Okay, and next, number 5, stable, unstable, stable and unstable system, stable and unstable, and invertible and non-invertible, invertible and non-invertible. So on this topic you'll get invertible and non-invertible. So on this topic you'll get one question, and if you look at the last year also, in ECE they asked one good question on this topic. So let's take a review let's take a review. So first of all, linear and non-linear system. Can you tell me, guys, what is linear and what is non-linear system? Linear means, tell me, linear means homogeneity and superposition. Homogeneity and superposition. Homogeneity and superposition. So if these two theorems, homogeneity and superposition, is applicable on any system, we call that system as linear. Okay, let's say I have a system. What is homogeneity? Let me teach you about homogeneity first. Let's say I have some system. If I double the input and the output will also get doubled, then we call the system is homogeneous. Okay, if you triple the input and the output get tripled, then we call that system is homogeneous. Okay, so I hope you understood how to check homogeneity. So it's very simple. Let's say homogeneity is not applicable at any system. Let's say homogeneity is not applicable. If homogeneity is not applicable, then you directly say that the system is non-linear. But if homogeneity is applicable, then you have to check for superposition. Okay, then you have to check for superposition. Now how to check for superposition? I'll tell you how to check for superposition. First of all, you have to check for homogeneity. Let's say you have yt here and xt here. Let me give you some example. So I say yt equal to e to the power xt. Now in the system you can see that this is non-homogeneous. Why? Because if you take xt as 1, then the output will be e to the power 1. But if you double the input, if you take xt as 2, then output will not be doubled. If you take xt as 1, output will be e to the power 1. Okay, output will be e to the power 1 if xt is 1. Now what you can do is you can double the input. If you can double the input, xt will be 2, but output will be e to the power 2. It will not be doubled, it will be squared. You can say that e to the power 2 is square of the e to the power 1. So you can say that here homogeneity is not applicable. If not applicable homogeneity, if homogeneity is not applicable, you don't need to check superposition. Directly you can say that the system is non-linear. Okay, I hope it is clear to everyone. Now there are some relations between input and output where you can directly check that this homogeneity is not applicable, and you can say that the system is non-linear. What are those relations? Number one, if the input and output are related via exponential relation, like I have shown here. Okay, so this is exponential relation. So if input and output are related via exponential relation or via trigonometric relation, number 3, via logarithmic relation, okay. Number 4, via multiple power, okay, via multiple power relation, okay. Or number 5, mode, via mode relation. You are taking mode, okay, that mode, MOD, okay. I don't know what's the spelling of the mode. I mean the magnitude. You are taking the magnitude mode only. So if input and output are related via these type of relation, then the system will be non-homogeneous. Okay, system will be non-homogeneous as well as non-linear. Okay, I have given you one example like this: yt equal to e to the power xt. On this system, you can't apply homogeneity. Okay, let's take one more example. I say yt equal to sine of xt. Yt equal to sine of xt. You can easily see that. If you are going to double this, let's say xt is 1, output will be sine 1. If xt is 2, output will be sine 2. And sine 2 is not the double of sine 1. That's why it will become non-linear. And here in this system, input and output are related via trigonometric relation. I hope you understood it. Okay. Now, let's say yt equal to ln xt. Similarly, this is again non-homogeneous. If the input is doubled, output will not be doubled. You can put xt as 1 and then 2. You can double the input, output will not get doubled. Okay. Now, let's say yt equal to mode of xt. Okay. If I take things like this, mode of xt, again, homogeneity is not applicable. Let's say xt is minus 1, or let's say xt is 1. If xt is 1, then output yt will be equal to 1. You have to take mode of this. Now what you are doing is you are multiplying xt with minus 1. Let's say you are multiplying input with minus 1 factor, but the output will remain same. Output will remain at 1. It means if you are multiplying xt with minus 1, then output should multiply with the same factor if the system is homogeneous. But the output will remain same. You are multiplying input with minus 1, but the output remains same. It means homogeneity is not working here. Okay, I hope you understood it. So that's why the mode relation is again non-homogeneous. Let me give you one more example, guys. There is one more case, number 6. In number 6, you can say that whenever you have some input output relation, and that input output relation is different in different zone. Okay, let's say there is this is my input xt, and this is my output yt. Let's say for this range, the input and output relation is like this, and for this range, the input output relation is like this. Okay, it means input output relation is different in different zone. Input output relation is different in different zone. You can see that. Then again, it is non-homogeneous. How can you say that? Let me tell you how I can say that this is non-homogeneous. Let's say you are putting the input 2 and the output came out to be 2 itself. Okay, let's say for 2 input, output is 2. Now if I multiply this input with minus 1, the input will become minus 2. Fine. For input 2, output is also 2. Now what I'm doing is I'm multiplying this input with minus 1 factor. If you are multiplying with minus 1 factor, it will become minus 2. At minus 2, the output is minus 1 only. It means input is multiplied by minus 1, but output is not multiplied by minus 1. For input x equal to 2, output is 2. Okay, you multiply minus 1 with the input, it will become minus 2. So the output should also become minus 2, na? If the system is homogeneous. Okay, so I hope it is clear to everyone. Now this system is non-homogeneous. Why it is non-homogeneous? Because if you multiply input with minus 1, output is not getting multiplied with minus 1 again. Okay, so that's why this is non-homogeneous. Now whenever you have a system like this, in which output and input are related like this, so the relation is yt is equal to mxt plus c. Now due to this c constant, again the system will be non-homogeneous. You can see that if you are doubling this will not get doubled because of c, because you are doubling only one factor, you are not doubling c part. Okay, that's why again this relation will be non-homogeneous and the system will be non-linear. So whenever you have this constant term, whenever you have this isolated term, the term without xt, you can see that the c is some isolated term. C does not have, C is not a coefficient of xt. With C, you don't have xt or yt. Input and output parameter are not there. So if you get something like this, then the system will be non-linear, or you can say non-homogeneous. If the system is non-homogeneous, then it will be non-linear for sure. Okay, so it will be non-linear. Okay, we call this C as energy in the system. It's the energy in the system, or maybe it's similar to energy in the system. Okay, the isolated term should not be there in the input-output relation. If isolated term is there, what I'm calling isolated term means the term which is not along with the xt or yt. Okay, we call that term as isolated term. So if in input-output relation you have some isolated term, it will be non-linear. You can directly say that. Okay, now let's take one more example. Let's say the relation is like this. This is my yt and this is xt. Now tell me about this relation. Yt is equal to, let's say there is some slope. The slope is 2, let's say 2xt. So this is the relation, guys. Now tell me, is it homogeneous or non-homogeneous? First of all, tell me, guys, is it homogeneous or non-homogeneous? Tell me, guys, is it homogeneous or non-homogeneous? If you are doubling the input, let's say input is 1, output will be 2. And if you are doubling the input, if you double it, output will get doubled. Output will also be doubled. Okay, so it means this system is, tell me, this system is homogeneous. This system is homogeneous. If the system is homogeneous, then I have to check for superposition. Okay, the system is homogeneous. If you double the input, output will also get doubled. Now you have to apply the superposition. How to apply the superposition? How to check for superposition? Okay, let me tell you how to check for superposition. What you need to do is, first you take input as x1t. Let's say input is x1t. So you'll get the output y1t. Then you take input as x2t. You'll get the output y2t. Then you get the input x3t. Take the input x3t. Then you get the output y3t. Now what you have done is you have selected this x3t such that it is the superposition of the previous two inputs. It means you can say that x3t I have selected as x1t plus x2t. You have selected x3t like this. Then the output will also get the superposition of the previous two output. If the output will also be the, if you take x3t such that it is the superposition of the previous two input, and the y3t is also the superposition of the previous two output, then you can say that if you have superposed the input, output will also get superposed. On this system, superposition is applicable, and if it is applicable, since it is homogeneous, if superposition is also applicable, you can say that the system is linear. Now let's check superposition on this. First of all, I put input as x1t. If input is x1t, then the output is y1t, and y1t is 2x1t. Fine? Is it fine? Now you replace input x2t. If input is x2t, output y2t will be equal to 2x2t. Fine? Because input is x2t. So output y2t is equal to double of that. Now you take input as x3t. So y3t will be equal to double of x3t. But now x3t can be replaced as x1 plus x2. x3t can be replaced as, because x3t I have selected as the superposition of the previous two input. And if y3t came out to be, if I replace y3 as y1t plus y2t, now you can see that whether this is equal to this. If these two terms are equal, then we can say that the superposition is applicable. So what I have done is, in place of x3, I have replaced x1 plus x2, and in place of y3, I have replaced y1 plus y2. Now you have to check whether they are equal or not. How to check? You can put y1 and y2t above, from this relation. y1 is 2x1t, y2 is 2x2t. So on this side, you put these values, and you can say that this side is equal to this side. So on this system, superposition is also applicable. Okay. So homogeneity is applicable and superposition is also applicable. So this system is linear. Is it fine, guys? This system is linear. I hope you understood it. So this system is linear because homogeneity is also applicable and superposition is also applicable. Okay. So whenever homogeneity, first you have to check homogeneity. Once you get the homogeneity is applicable, once you get this, then you have to check for superposition like this. You take first as x1t, then x2t, and correspondingly y1t, y2t you can write, and then x3t. Okay. So corresponding y3t you can write. Now replace x3t with x1 plus x2 and y3 with y1 plus y2 and check whether these two sides are equal or not. You can take y1 and y2 like these from these equations you can put the value of y1 and y2 and you can check whether this side or this side are equal or not. If they are equal, it means superposition is applicable. So it's easy peasy. Okay. I hope you understood it. Now let's take one example, and the example is there is a system. Okay, before that example, I want to tell you one more point. There is one more thing that you need to remember in linearity, and that thing is there are some linear operations. There are some linear operations and there are some non-linear operations. What are linear operations? If the input and output are related via linear operations, then the system will be linear, and if input and output are related via non-linear operation, then the system will be non-linear. What are those linear operations? Let me tell you about linear operations. Linear operations are addition, subtraction, differentiation, and integration. These are linear operations. It means if input and output are related via these operations, then the system will remain linear. And there is one more thing, non-linear operation. Non-linear operation. What are those non-linear operations? Tell me, guys. Multiplication and division. Multiplication and division. These are non-linear operations. It means if input and output are related via multiplication, okay, we call it non-linear operation. Now let's say yt is equal to xt into x of t minus 2. Let's say I write that like this. Now you can see that this is input parameter and this is input parameter, so they are multiplied. If they are multiplied, then the system will be non-linear. You can directly say that the system is non-linear. Okay. If I take yt equal to sin t into xt, tell me, guys, will I call it multiplication? No, this is not a multiplication of two input parameter. Though it's a multiplication, sin t is multiplied with xt, that's correct. But in multiplication or division, which multiplication we are interested to see? The multiplication in which input and output parameters are multiplied. Let's say input is multiplied with input, or let's say input is multiplied with output, or output is multiplied with output. So we will consider only those multiplication and division, not this, because in this case sin t is multiplied with this. Sin t is not an input parameter, okay? So that's why you have to be careful. This is a linear operator, this is a linear system. You can see that homogeneity is applicable. If you double this, this will also get double. Let's say xt is 1. If xt is 1, output is sin t. If xt is 2, output is 2 sin t. It means the output get doubled. So this is homogeneous, and this is I mean, you can say a superposition is also applicable. You can check it. So this system is linear. This system is linear. So don't confuse with the multiplication and division. Multiplication and division between inputs and output parameter you have to see. Okay. So be careful, guys. Be careful about this. Now many students will ask me, sir, but this is the trigonometric relation, na? This is the trigonometric relation. So, and you have told that if the system is if the system input and output are related by a trigonometric operation, then it will be non-linear. You have already told that. We have already told that. Trigonometric relation, non-linear, non-homogeneous. So it will be non-linear. No, sir, this is not trigonometric relation. If it is right like this, yt equal to sine of xt, then I will say that input and output are trigonometrically related. Yt is sine of xt, but here you can see that sin t into xt is there. Okay, so don't confuse with this. This will act like a coefficient. This trigonometric function will act like a coefficient. It is yt is not the function of sine of xt. Okay, so be careful. There is a difference. There is a minute difference in this and this. Okay, so be careful. So I told you, whenever there is a multiplication or division, then I call that the system is non-linear. Now let's take one example. Yt equal to dxt by dt. Tell me, guys, yt equal to dxt by dt. Whether it is linear or non-linear. Tell me, guys. You can see that input and output are related via differentiation. Input and output are related via differentiation. So differentiation is a linear operation. So the system will be linear. Tell me, guys, is it correct? Now if I take yt equal to double derivative d square xt by dt square. Tell me, guys, yt is equal to d square xt by dt square. Now again I have taken double derivative. It is not square, it is double derivative. If you have taken double derivative, again system will remain linear. Why? Because I am not squaring it. But if I square it, tell me, guys, if I square it, then it will become non-linear. Then it will become non-linear. Is it fine, guys? Then it will become, because this xt parameter is multiplied with itself. So there is a multiplication operation now. If the multiplication operation is there, system will be non-linear. Okay, so please remember this point. Now let's take one more example. Yt equal to xt plus 1. Tell me, guys, linear or non-linear? d square yt by dt square plus 4 dyt by dt plus yt equal to xt. Tell me about this system. The first one, please tell me about the first one first, and then second one. Tell me, what about this system? Is it linear or non-linear? Tell me, guys. This system is non-linear because of this term, because of this isolated term. This term came without xt or yt. That's why this system is non-linear. Okay. What about this system? What about the second one? Tell me, guys. What about the second one? Do it fast. Tell me the second one. The second one. Tell me about the second one. Everyone, do it fast, because I want to do everything in a fast manner, because these things are very easy. So tell me the second one. Second one. Tell me, guys. Tell me fast. The second one. In the second one, if you see, you have taken double derivative here. Double derivative doesn't disturb the linearity. Now here also you are taking double derivative, single derivative. So no problem. You are not taking any derivative. No problem. It's simple xt. And now you have added. Addition is a linear operation. So there is no operation which is violated here. There is no non-linear operation. So the system will be linear. System will be linear. Okay. Now you can see that whatever things we have applied, we have not violated, I mean, we have applied only these linear operations. Either there is differentiation or addition. Now you'll see, sir, there is a multiplication of this, na? Yes, 4 is multiplied here. But I will not consider this as multiplication, because multiplication between input and output parameters should be there. Either input input or input output or output output. But it is not multiplied like this. Okay, it's a coefficient. It's a coefficient here. That's why the system will be linear. Now, if I add xt plus sin t, tell me guys, what will be this? If I add this extra term, will it be linear? Tell me guys, will it be linear? Is it buffering? I think it's not buffering. It's not buffering, guys. Tell me, what is this now? Is it linear or non-linear? If I add this sin t term, will it be linear? Say yes or no. Tell me guys, will it be linear or will it become non-linear? Tell me everyone. What I have done is I have added xt plus sin t. If I have added xt plus sin t, please reply. Reply everyone. Now it will become, everyone, tell me. Now it will become, tell me everyone, you are not replying. Yes, now it will be non-linear. Why non-linear? Because this term is without xt and yt. This is isolated term. So it will act like a c, constant c. Okay. Though it's not constant, but it's some isolated term. So it will make the system non-linear. Okay. So be careful guys. On this type of system, whenever you have constant term or maybe isolated term, on that system, homogeneity is not applicable. Okay. That's why it will become non-linear. I hope you understood it. Now let's take an example. I have yt is equal to, there is one good example, yt is equal to 1 by xt dxt by dt and take the square of it. First of all, I want to ask you whether this system is homogeneous or not. Please tell me whether this system is homogeneous or not. Is it homogeneous? If you double the input, will the output get doubled? If you triple the input, will output get tripled? First of all, I want to ask you about homogeneity only. Whether this system is homogeneous or not. Tell me guys, whether this system is homogeneous or not. Is it homogeneous? Actually, it is homogeneous. You can see that if you double the input, let's say xt is doubled, so make it 2 times of xt. So if I take 2xt, it will become like this, d by dt of 2xt. Is it fine? I can write like this and you have to take square of it. So take this 2 out. If you take this 2 out, it will become 2 square. So it will become 2 square here. Okay, 2 square upon 2xt into d by dt of xt square. Okay, I have taken this 2 out from this square and here I have cancelled it. So you can see that if you double the input, if input get doubled, then the output will also get doubled. Previously the output was this, now the output is, you have extra 2 factor. So you can see that if you are doubling the input, output get doubled. So this system is homogeneous, but it is non-linear. This system is non-linear. Why it is non-linear? Because superposition is not applicable. Here the operation is division. Xt is in the division. Denominator. Okay, xt is in the denominator. That's why the system will be non-linear. Okay, remember, homogeneity is applicable, but superposition will not be applicable here. Okay, so that's why I told you, if homogeneity is applicable, you have to check for superposition, but you don't need to check for that now, because you can directly see that xt is in the denominator, or these two are multiplied, or there is a square of that. That's why there are so many things. Depending on that, you can say that this system is non-linear. But I don't ask you about non-linearity. I ask you about homogeneity. So this system is homogeneous. That's correct. Okay, but it is non-linear. I hope you understood it. Now let's take. Okay, so I told you about linearity. I told you about linear and non-linear system. How to check whether the system is linear and non-linear. So these are the rules. Now let's come to time variant and invariant system. Okay. Okay, let's come to time variant and invariant system. Before that, I want to take one more example. I told you that if your system is such that input output relation is different in different zone, you can see that if xt is greater than -1, input and output is this, relation is this line is represented by this line. And if input is less than -1, if the input is less than -1, the relation is different. Okay, so if you are getting different relation in different zone, then the system will be non-linear. Homogeneity will not be applicable in this type of system, so you have to be more careful about that. Okay, let's come to the next thing. Next thing is time variant and invariant. How to check whether the system is time variant and invariant. Okay, let's come to time variant and invariant. Time variant and time invariant system. Let's say you have a fan. Okay, let's say you have a fan at your house. In your fan, you give the supply 220 volt and it start rotating at, let's say, 800 rpm or maybe 400 rpm, whatever. Let's say it start rotating at 800 rpm. rpm means revolution per minute. Okay, let's say it start rotating at 800 rpm. You supply some voltage, you switch it on. Now if you give same supply on the next day, if you give the same supply on the next day, after some delay time, if you provide the same supply input, if you provide the same voltage, will the fan say that no, I will not run now, I will not rotate because you have switched on Wednesday or Friday, on Thursday, because Thursday is my holiday, so I will not work. Will the fan will say like this? Say yes or no? Obviously fan cannot say like this. Fan the speed should also be 800 rpm again. So if you are giving the supply to the fan, whether you are supplying you are giving the input at some t time or t naught time or maybe after some time, at whatever time, if the supply input is same, then the output will also remain same. Okay, we call it time invariant system. So time invariant system are those system in which if the input remains same but you are providing delayed input, you are just delaying it, the shape of the input remains same. Let's say you have a system, and in this system you are providing some input xt, and let's say the xt shape is like this, 0 1, and the output came out to be like this. Okay, 0 1 2. Let's say this is my output of this system and this is the input. Now what you are doing is you are delaying this input, keeping the shape same. If you are delaying it by 1 second, let's say this is the new input now, for this input, if the output shape will also remain same, the only thing is, since you have delayed the input, output will also get delayed by the same amount. Output will also get delayed by the same amount. Then we call that the system is time invariant. Okay, you have kept the shape same, only thing is you have delayed it by 1 second, so the output shape will remain same, the only thing is output will also get delayed by 1 second. Okay, we call this system as time invariant system. This is time invariant system. Now what is the meaning of time variant system? Time variant system means, in time variant system, either the shape will change or the delay will be different. Okay, if you are keeping the same input, if you are keeping the shape of the input same and you are delaying the input, then output, either the shape of the output will change or the delay will change. Okay, we call that system as time variant system. Now how to check whether the system is time invariant or variant? Let's say you have input output relation. If in an input output relation, look at the coefficient first, coefficient of xt or yt, whatever. If the coefficient is time dependent, let's say the coefficient here is t, since this coefficient is time dependent, xt is multiplied with some other function which is time dependent. Now in this case it will be a time variant system. Okay, it will become time variant system. We call it time variant system. Why we are calling time variant system? Because let's say you are supplying this input. If you are supplying this input, whatever input you supply, output will be multiplication with t. So whatever input you are supplying, multiply it with this t line. The graph of this t line is like this. Okay, so whatever input you are supplying, this is the input you are giving to the system, multiply it with t and you will get the output. So the output shape will look like this. Output shape will be the product of this and this. So the product will exist between 0 and 1 only, okay, because after 1 this is 0, this function is 0, so the product will become 0. So between 0 and 1 you will get the product. Between 0 and 1 this height is 1 and this height is t. So you can say this will be the output. Is it fine, guys? This will be the output. Okay, this will be the output if you are supplying this input. Now if you are supplying this input, what will happen, guys? Whatever input you are supplying, multiply it with t. T is this line. Now the input is this, we have to multiply this input with this t. So if you multiply it, since the product will exist between 1 and 2, so 1 and 2, whatever the t value is, multiply by 1. So you'll get the output like this. Between 1 and 2, you'll get the output, and the output will look like this. Is it fine, guys? Okay, output will look like this, 1 and 2. Why it is like this? Because between 1 and 2, look at the t value, look at this t, multiply it with 1. Okay, whatever this t is multiplied with 1, you'll get the t again. So this will be the shape. So you can see that if I delay the input by 1 factor, output will also get delayed by 1, but the shape has changed because the coefficient is time dependent. So whenever you have coefficient time dependent, then remember the shape will change and the system will become time variant. Okay, we call it time variant system. Now let's take some example. Tell me about this system. Is it time variant or invariant? Tell me about this system. Is it time variant or invariant? Tell me, guys, whether this system is time variant or invariant. Do it fast. Tell me whether this system is time variant or invariant. Tell me, everyone. I want you to reply it. Tell me whether this system is time variant or invariant. Is it time variant or invariant? Yes, it is time variant because of this sin t. That's why this system will become time variant. Now, what about this? Tell me. What about this? Is it time variant or invariant? The second one, this sine of xt. Tell me, is it time variant or invariant? You can see that there is no coefficient time, there is no time dependent coefficient. This is not a coefficient now. So in this case, it will be time invariant. Okay, this is time invariant. So please be careful about it. Okay, now what about this? Tell me, guys, what about this? Is it time invariant or variant? Tell me. Yt equal to xt into x of t minus 2. Is it time variant or invariant? Tell me, is it time variant or invariant? Let's see how the output will look like. Okay, so let's say yt is equal to, I have yt is equal to xt into x of t minus 2. You have this relation between output and input. You have this relation, yt equal to xt into x of t minus 2. Now what you can do is you can put some input. Let's say the input is like this. You can take any input, na? Okay, so what I have done is I have taken this input 0, 1, 2 and 3, and this height is 1. Okay, let's say this is my xt input. If this is the input, what is the output, guys? What is the output? Output is product of this and the delayed value of this. So product of this and the delayed value. Now what is the delayed value? Delayed value, you can delay it by 2. Okay, and it will be up to 5. Okay, so this is x of t minus 2. If this is the input, this is the delayed version of this input. If you multiply them, you will get the output between 2 and 3. The product will be exist between 2 and 3. Between 2 and 3, it is 1 and it is also 1. So if you multiply it, you will get one output. You will get one output between 2 and 3. Is it clear, guys? So the product will be between 2 and 3 only, and the product will exist, and the product will be 1. Because between 2 and 3, you can see that before 2, this function is 0, and after 3, this function is 0. So if you are multiplying them together, Between 2 and 3, this is 1 and this is also 1. So the product will exist. Fine. Now what you are doing is, you are delaying this input. Okay. So delay it. Let's delay it. If you are delaying this input, let's see whether the output will also get delayed by the same factor. So if you are delaying it, let's delay it by 1. If you delay it by 1, the input will look like this. 1, 2, 3, 4. This is my input now. This is my xt now, new xt. This is my new xt. I have delayed it from the previous value. Okay. So this will be the new xt. Let's call it x1t. Now output will be multiplication of this input and delayed version of this input. What is the delayed version of this input? Let's delay it by 2. If this is x1t, the new input, then the output will be x1t into x1t minus 2. So you have to delay it by 2 seconds. If you have to delay it by 2 seconds, then this 1 will appear at 3. Okay, and this 1 will appear at 3. This is 4, 5 and 6, I suppose. Okay, so I have delayed it by 2. This is x1 t minus 2. If you multiply them together, now tell me guys, if you are multiplying them, the product will exist between 3 and 4. The product will exist between 3 and 4 and the height of the product will be 1. Is it fine, guys? You can see that the height will remain as 1 and the product will exist between 3 and 4. Product is existing between 3 and 4 and the height remains at 1. So previously you have put this input and the output was this. Now you have delayed this input. So the new input is a delayed version of the previous one and you have delayed by 1 second. So the output will also remain same and the output will also get delayed by 1 second. Is it fine? So tell me, guys, according to this, it should be time invariant. But this is the only one case, na? You have to check other cases also, because you can't say by just checking one case, you can't say that this is time invariant. There should be, I mean, if there is, let's say, if there is only one example which is not satisfying this, let's say, there are almost every example is satisfying this condition. If you are delaying the same, the output will also get delayed by the same factor and the shape remains same. But let's say there is one input is such that it is not satisfying this condition, then we will say that the system is time variant. Okay, system will be time, but according to this, it is time invariant. Okay, but this is the one example. I mean, you have checked only one example. You have not checked it entirely. So this is the main problem. So how to check it? How to check it, guys? How to check it? How to check whether the system is time variant or invariant? Tell me, guys, is it time variant or invariant? According to this, it is time invariant. According to this example, it is time invariant. But this is a single example. Now tell me how to check. How to check? Okay, this is your I mean, you have to do it, or maybe I will take it after completing some topic. Then I'll tell you what is this time variant or invariant. Till then you can think about it. Okay, so this is your homework, let's say. Okay, think about it whether this is time variant or invariant. According to this example, this is time invariant, but can you apply can we do some more permutation combination or some type of example you can see in which you are getting different output? Okay, if you are doing this, you will get different output. Can you get some idea about that? Okay, so think about it. Anyway, let's come to the next case. Let's come to the so I told you about the time variant and invariant case. Okay, now I told you if the coefficient of xt is time dependent, then it will become time variant. But there is one more case which will make the system time variant. And what is that? Look at this term. Look at the inside term. Let's say yt is equal to x of minus t. Now the coefficient is time independent, but the inside term, this is minus 1. Now we have to check whether this is time variant or invariant. Tell me, guys, whether it is time variant or invariant. Tell me how to check it. So there is a direct method for checking this. One is direct method, or one is this method. This actual method you can apply. But if you apply this actual method, obviously it's very lengthy. It will become very lengthy. It will become very lengthy. This method is very lengthy. So what you can do is, you can apply direct method. What is the direct method? Let me tell you the direct method. What you can do is, whenever the relation is given like this, and if the coefficient is time independent, coefficient is not time dependent, you can see that. Coefficient is time independent. Then what you can do is, you can apply direct method. What is the direct method? What you can do is, inside, look at this inside term. What you can do is, you subtract minus t. Whatever the term is, you subtract minus t from it. Okay? This is the first step. You subtract minus t. Or, and the second term, what you can do is, in the second case, what you can do is, you replace t with t minus t. What I have done is, I have replaced t with my t minus t. And in the second case, what I have done is, I have subtracted minus t from this entire term. So we have, inside this bracket, we have minus t here, and here you will get x of minus t plus t. Is it fine? Since you have different terms inside this bracket, you have different values, different expression, so the system will be time variant. The system will be time variant. You can directly check like this. You don't need to check for these type of system. First you apply this and check the output, and then delay it and then check the output. It's a very tedious process. It's a very lengthy process. Okay, it's a very lengthy process. So what you can do is, you can check it like this. You can check it like this. What you can do is, whatever inside term is, first you subtract capital T from the complete term. Let's say the complete term is minus t. So you subtract capital T from this entire term, and in the second case, what you do is, you replace t with t minus t, and check whether this term or this term are equal or not. If they are equal, then the system will be time invariant. If they are not equal, the system will be time variant. You can check it directly like this. Okay, so this system is time variant. The system is time variant because this term and this term are not equal inside the bracket term. Okay, now tell me about this yt equal to x of 2t. Let's take an example. And what example I am taking? Yt is equal to x of 2t. X of 2t. Tell me, is it time variant or invariant? Tell me guys, is it time variant or invariant? Do it fast. Whether it is time variant or invariant. Tell me everyone, whether it is time variant or invariant. Time variant or invariant? Everyone, tell me whether it is time variant or invariant. Yes, it is time variant. Why it is time variant? What you can do is, look at this bracket term. Coefficient is time independent, so you have to look at the bracket term. Inside the bracket you have 2t. So first subtract capital T from this entire term, and in the second case you replace t with t minus t. So it will become 2t minus 2 capital T. Now you can see that this term and this term are different. That's why you can say that this system is time variant. Okay, so this way you can check it. I hope you understood it. Now let's take an example. Yt is equal to xt dt from 0 to t. From 0 to t. Tell me about this, whether this system is time variant or invariant. And in the second case, what I'm doing is yt equal to 0 to 2t xt dt. Tell me about this, whether the system is time variant or invariant. The first one and the second one. Tell me. The first one, this is first one and this is the second one. Tell me, first one, time variant or invariant? Whether this system is time variant or invariant, and whether this system is time variant or invariant. Yes, the first one is time invariant and the second one is time variant. Okay, this is time variant and this is time invariant. Why? The best way is, you can take the input, you can take some input like this, and you can calculate the output in the first case and the output in the second case, and then delay it. You will see. The other method is, what you can do is, you can see that this limit t has to, if you solve it, then you have to put the limit here, na? If you solve the integration, then after solving the integration, you have to put the upper limit minus lower limit, na? So it means this upper limit will appear inside this xt, whatever the integration answer is. inside that bracket you have to put this xt, and whatever the output is, whatever the integration is, you have to put 2t inside the bracket. Okay, 2t limit you have to put. It means this 2t term and t term will be inside the bracket. Okay, inside the bracket, this will appear in the output. Now you can see that here in this case, first you subtract capital T from this entire term, and the second is you replace t with t minus capital T. Now you can see that these two terms are not equal. That's why this is time variant, and here it will become time variant. Okay, time invariant. Here it will become time invariant. I hope you understood it. Okay, so be careful, guys. This is again simple case. Okay, so I told you how to check whether the system is time variant or invariant. Now let's take one more example. I want to erase all the slides. Okay, let me erase this and let me add some slide. Let me add some slide so that I can continue with this. Okay, okay, so I told you about linear and time invariant. Now let's come to causal and non-causal. Okay, let's come to causal and non-causal. Now tell me about causal and non-causal. Causal and non-causal. Let's look at this, causal and non-causal. The causal system means the system in which you get the output after putting the input. Okay, that system are called causal system. It means output will not appear before the input. If output is appearing before input, we call it non-causal. Before providing the input, if output appears, we call it non-causal. Okay, remember this point. Whenever the output appears after applying the input, then we call this system as causal system. But if the output appears before the input, let's say output appeared before the input, we call it non-causal. It means you have not provided the input and output appears. So we call it non-causal system. Okay, so you have to be careful about causal and non-causal. It means you can say that the present output depends on the present input or past input. Then the system is causal. Causal means practical, you can say. So if you look at the practical system, in any practical system, output will appear only because of the present input or the past input, the previous input that you have provided to the system. So you can say that the system will be causal if the present output depends on the present input or the past input. But if it depends on the future input, then it will be non-causal. Future input means input is not there, input will be applied in future and still you are getting output. Okay, so that type of system will be non-causal. Now how to check it? Let's say yt equal to x of minus t. You have to check the system whether it is causal or non-causal. So how to check it? The simple way is, inside this bracket term will tell you, this term inside this bracket, okay, the variable, time variable, that will tell you about the causal and non-causal system. How to check it? Let's take t as 1. Let's take t equal to 1. If you take t equal to 1, then this relation will be y1 equal to x of minus 1. Right? It means at t equal to 1, you are getting the output. And the input has to be at minus 1. At minus 1, you can see that at 1 you are getting output, but the input has to be at minus 1. So this is correct. The output is getting after the input. First you have to provide the input because time is increasing now. So time is increasing like this. Time is going like this. So first you have to apply input and then you will get output. So according to this, it is practical system. It is causal, but it is only the one input you have checked. Now what I can do is I can put t equal to minus 1. Let's say at t equal to minus 1, what happens? If you put t equal to minus 1, then it will become y of minus 1 is equal to x of 1. It means you are getting output at minus 1. And the input has to be at 1. So if time is increasing, so you can see that first you will get output and then you will get input. So output is getting before that input. Okay, so that's why the system will become non-causal. You have to check the inputs like this. I mean, the time, according to the time you can say that the causal is that the system is causal or non-causal. What you can do is you can put the value of t like this. So how to check? I mean, you have to be, every time you have to put some values now. So it's not the random values. What you can do is first you put 1, then -1, or then 0 to 1. You take t between 0 and 1. Okay, I mean the positive value you can put, and then take t value between -1 and 0. Okay, wait a minute. Then take the t value as t greater than -1 and less than 0. Okay, it means between 0 and -1. So you have to take 4 values. First you take 1 or -1, 2 values, you can check these 2 values, and then take t value between 0 and 1, and then between 0 and -1. Moreover, you can also take t equal to greater than 1, not equal to, t greater than 1 and t less than -1. You can also check by putting these values. So there are actually 6 combinations. So you can check these values, and let's say at -1, if you put t equal to -1, then it will become non-causal, then stop it. You don't need to check any other. If anyone is violating the rule, any one input is violating the rule, any one time instant is violating the rule, we call it non-causal. Okay, let's take yt equal to x of t square. Now tell me whether it is causal or non-causal. Tell me guys whether it is causal or non-causal. Tell me guys whether it is causal or non-causal. Tell me how to check it. Again, you have to put the t value, no? You have to put the t value. So what you can do is, let's take t value. So I am taking t as 1. So if you are taking t as 1, so you'll get y1 is equal to x1. It means at t equal to 1, you are putting the input, and at the same time you are getting the output. So you can say present input depend on the present output. Okay, present output depend on the present input. You can say like this, because input is at 1 second and output is also getting at 1 second. So present output depends on the present, but this is the only one value. What you can do is you can take t as 0.5. If you take t as 0.5, then y.5 is equal to x of square of this 0.5. Square of 0.5 is 0.25. Fine. It means you are getting output at 0.5. You are getting output at 0.5, and the input is at, tell me, the input is at 0.25. So again, according to this also, the system is causal. Okay, according to this also, the system is causal. Fine. You can see that the first you have to put the input and then you will get the output. So actually the system works like this. First you have to put the input and then you will get the output. Now let's take t equal to 2, greater than 1. I have taken the t greater than 1 also. If you take t equal to 2, you will get y2 is equal to x of 4. Now you can see that you are getting the output at 2 and you are getting input at 4. So first you are getting output. First you are getting output and then you are providing the input. So in this case it will become non-causal. And I told you, if in any single case it will become non-causal, the system, I will say that the system will be non-causal. So this is non-causal system. This is non-causal system. Is it clear guys? I hope you understood it. So this is non-causal system. Okay. Now let's take yt equal to x of root t. Tell me whether it is causal or non-causal. Tell me guys whether this system is causal or non-causal. Do it fast. Whether this system is causal or non-causal. Tell me everyone. Tell me whether this system is causal or non-causal. Do it fast. Whether this system is causal or non-causal. You can check now again. 1. First you check at 1 and then 0.5. Okay. You have to check. You have to take any value. Take t equal to 1, and then between 0 and 1 you can take, and then greater than 1 value you can take. Any value greater than 1, any value, like 2 or 3 or 4 or 5. Okay. So you can check like this. This is non-causal. Yes, this is non-causal. Why? Let's say t equal to 0.5. If you take t equal to 0.5, between 0 and 1 I take. So y of 0.5 is equal to x of root of 0.5. So x of root of 0.5 is approximately 0.7. Okay, and y of 0.5. So you can see that you are getting the output before the input. You are getting output here and the input is here. So you are getting the output before the input. That's why we call it non-causal. The system is non-causal. I hope you understood it. Okay, so let's proceed, guys. I told you about the causal and the non-causal system, how to check whether the system is causal and non-causal. Okay, now come to the next, static and dynamic. Static and dynamic. What is static? Static means memoryless system. Static means memoryless system. A system will be static if the present output depends on the present input only. Memoryless. It doesn't have memory. If the system doesn't have memory, it cannot store the previous value or the future value. It means the present output depends on the present input only. If you put t equal to 1 on this side, it has to be 1 on this side. Okay, so we call that system as static. Let's say yt equal to 2 of x, sine of xt. Let's say this is the system, sine of xt. Now tell me whether this system is static or dynamic. Tell me, guys, whether this system is static or dynamic. This system is static. Why? Because if you put t equal to 1 here, you'll get the output 1. If you put t equal to 2, you'll get output 2. Okay, sine x of 1, you'll get y1. It means you are getting output at 1 and the input is also 1. So the present output, let's call it present output. Let's at t equal to 1, whatever output you are getting, let's call it present output. So present output depends on the present input value. Okay, that's why I call this system as static system, memoryless system. Okay, yt equal to xt square. Yt equal to xt square. Okay, now tell me, if you put t equal to 1 here, you'll get 1 here. If you put t equal to 2, you will get t equal to 2. It means the present output depends on the present input. Is it fine? So this system is again static. So static means the present output depends on the present input. It does not have the future or maybe past. Now let's say yt equal to dxt by dt. If I say yt equal to dxt by dt, now tell me, if I say yt equal to dxt by dt, then tell me about this system, whether it is static system or dynamic system. In the derivative means change. Change, for looking at the change, you need the past value or the future value. With respect to past, you are looking the change, or maybe with respect to future, you can see the change, because you can say that in future your shape is like this, your face structure will be like this. Okay, so you can say that the change can be represented with respect to past or with respect to future. So that's why the system is not static. Wherever there is a differentiation, it means the system is not static. The present output does not depend on the present input. Derivative means change. You have to take the change. For change, you need the past value. If you want to look at the change, you need the past value. That's why the system is dynamic. Similarly, if you take yt is equal to integration of xt dt like this. Okay, let's say you are writing like this. Now tell me, this system is again dynamic. Why? Integration means accumulation. It has started accumulating from minus infinity to, it means from minus infinity it has accumulated the value. That's why the system will be dynamic. Okay, so whenever you see the differentiation or integration, directly you can say that the system is dynamic. It will not be static. Okay, so because it depends on because integration means accumulation, the past values will get accumulated. Okay, and the differentiation means change. Change has to be seen either with respect to past or future. So it means there is a future term or past term is there. Okay, that's why we call it dynamic system. I hope you understood it. Static and dynamic. I'm giving you just simple idea. I'm not going into the rigorous analysis because it will take time, and I'm just revising the things. Okay, anyway, let's come to the stable and unstable system. Now what is stable and what is unstable system? For the time being, you can call that if the system, if there is a system, and in that system if you provide bounded input and the output will also be bounded, then that system is called BYJU'S stable. Okay, we call it BYJU'S stable. So from the time being, you can check for BYJU'S stability. Bounded input, bounded output stable. How to check it? if you provided bounded input to any system and if you get bounded output, bounded means the amplitude is bounded, okay, bounded means the amplitude is bounded. So if you are providing the bounded input and you are getting the bounded output, then the system will be stable. Let's take an example. Yt is equal to integration of xt dt. Okay, please tell me about this, whether it is stable or unstable, whether this is stable or unstable. And yt equal to e to the power xt. Let's say, let's first look at this. Let's say you are providing input some finite value, some bounded value. Input is, let's say, 1 or 2 or 3, whatever. But it is bounded, its value is bounded, its amplitude is bounded. So if you are providing some bounded amplitude, you are providing some bounded amplitude to xt, so the output will also get bounded. If you are providing some finite value to xt, output will also be finite. Okay, so it's a stable system. This system is stable. But what about this system? This system is unstable system. This system is unstable system. Why? Why it is unstable? Tell me, guys. Why this system is unstable? Why this system is unstable? Tell me, everyone. Because let's say xt is ut. Xt is ut. Okay, xt is ut. It means you are providing the bounded input for all time from 0.0 onward. All time the input is 1. It means input is bounded. What about the output? Integration of xt is rt. Integration of xt between 0 and t is rt. Okay, so the output will be like this. It will keep on increasing with time. It will keep on increasing with time. It means you can see that the system input is bounded, but the output is not bounded. Output is keep on increasing. That's why the system will be unstable. This system is unstable. Is it fine, guys? Now tell me about yt equal to 1 over xt. 1 over xt. Tell me whether this system is stable or unstable. Tell me, everyone. Yt equal to 1 over xt. Whether the system is stable or unstable. Tell me, everyone. Stable or unstable. Do it fast. Do it fast. Yt equal to 1 over xt. Whether this system is stable or unstable. Tell me, everyone. Tell me whether the system is stable or unstable. Do it fast. Do it fast. Do it fast. Yes, it is unstable. Why it is unstable? Because if you put xt as 0, 0 is bounded again. If you put xt as 0, it will become unbounded. Okay, that's why the system will be unstable. This system will be unstable. Now yt equal to ln xt. Ln xt. Tell me, guys, whether the system is stable or unstable. Tell me, everyone. Yt equal to ln xt. Whether the system is stable or unstable. Tell me, everyone. Whether the system is stable or unstable. Tell me. Is it stable or unstable? Everyone, please do it. Yt equal to ln xt. It is unstable again. Why unstable? Because if you put xt as 0, if you put xt as 0, so ln 0 is minus infinity. Ln 0 is minus infinity. Fine. So that's why we call it unstable system. This system is unstable. This system is unstable. Okay. Xt is 0. So xt is bounded, you can say. And the output is minus infinity. That's why the system is unstable. I hope it is clear to everyone. Now we can proceed. So I told you about the stable and unstable system. Now let's come to invertible and non-invertible. But let me tell you, stable and unstable can be checked with many things. I told you about the BYJU'S stability, how to check BYJU'S stability. But since you have studied, let's say some discrete signal is there. In discrete system, not signal, let's say, because signal can't be stable or unstable. Signal is a signal. Signal has information. You can't say that this is the stable signal or this is the unstable signal. No, system can be stable or unstable. Okay, signal you can't say. So let me again tell you, this is BYJU'S stability. But since you have more tools like Laplace transform and Z transform and then convolution, okay, so according to that you can also check stability of the system. How to check it? Let's say using Laplace, let's say you have a function ft and the Laplace transform is fs. Okay, let's say the system has some impulse response. Let's say you know the system impulse response. Let's say this system is LTI, linear time invariant. I'll tell you what is linear time invariant means. Even you know that, linear and time invariant. If the system is linear and time invariant, and ht is called impulse response of the system. What is ht? ht is called impulse response. What is the meaning of this? impulse. Impulse response. Okay, let's say ht is by impulse response. It means if you are providing impulse to the input, impulse as input, then the output will be ht. The response is ht itself. That's why we call it impulse response. And let's say the system is LTI, linear time invariant. We need to check the stability of the system. We need to check the stability of the system. How to check the stability? There are multiple ways. What you can do is you can calculate the transfer function of the system, TS. TS means output ys over xs. You can calculate the transfer function and then look at the pole of the system. Using the pole condition, you can check whether the system is stable or unstable. Using the ROC also you can check whether the system is stable or unstable. Okay, like if the system is discrete time system, let's say you can calculate, let's say this is a discrete time system, HN is provided. HN is again impulse response. Okay, if you provide delta n input, then the response of the system is HN. That's why I call HN as impulse response. Impulse ka response. If you provide impulse, then the response will be HT in continuous time domain and HN in the discrete time domain. So what you can do is you can take the Z transform of this. Using the Z transform, you can also comment on the stability of the system. Okay, you'll get HZ. The Z transform of HN is HZ. Now what you can do is you can check the pole and zero location, the pole location especially. Okay, and using the ROC concept, you can apply, you can say the system will be whether the system is stable or unstable. Using the ROC, you can check whether the system is stable. I think you must have studied this, no? I think you must have studied this. Ankit Joshi sir has told you about this, stability. How to check whether the system is stable in discrete time domain. So that thing is also applicable in continuous time domain. You can take Laplace transform. Using the Laplace transform and ROC and pole location, you can again tell us about whether the system is stable or unstable. Okay, is it fine, guys? So I hope it is clear to everyone. There is one more way to check whether the system is stable or unstable, but this method, this HT method or HZ method or HS method, this will not be applicable in this situation. Why you can't say that here you can't find, I mean, can you find HT here? No, you can't find HT here. The problem is, no, you can find HT, no doubt, you can find HT, but the problem is you can't check it using Laplace transform. The problem is this is not linear. This is not linear. If it is not linear, you can't find transfer function of this system. So you can't see the pole of this system. That's why on this system, wherever you have relation of xt and yt, wherever input and output relation are provided to you, wherever input and output relation are provided to you, use Bebos stability method. Use Bebos stability method. Okay, and whenever impulse response is provided to you, then you can use Z transform method, Laplace method, or there is one more method. Okay, there is one more method that is called, I mean, let's say they have provided you the impulse response of the system. They have provided, and you have to check whether the system is stable or not. So what you can do is you can calculate the area of mode of this function. Okay, if this is finite, if this area is finite, if the area of this finite, HT, area of the mode of HT is finite, then we call that the system is stable. Okay, then we call that the system is stable. So remember this point, guys. Using impulse response, you can check whether the system is stable or not. Okay, whether the system is stable or not. So it's again important because you can check the stability. Similarly, HN, on HN you have to take summation. Okay, on HN you have to take summation. I hope it is clear to everyone. Okay, let's proceed, guys. So I told you how to check the system stability. So there are multiple ways to check system. I mean, you have to look which relation is provided, whether you have provided with HT or the input output relation or the Laplace transform. Okay, if you can calculate the Laplace transform, you can calculate the transfer function or the Z transform. If you can do it, then you can go with the ROC and the pole location. Okay, go with the ROC and the pole location, then you can go with that. But if let's say you don't know the Z transform, or let's say input output relation is provided, they haven't provided you the Laplace transform of this, they haven't provided you the HT or whatever. Okay, then you can apply this Bebos stability. It means you have to be selective where to apply the Bebo stability case, where to apply the Z transform case, where to apply the Laplace transform case, and where to apply this integration rule. Okay, is it fine, guys? I hope it is clear to everyone. So this way you can check the stability of the system. You can check the stability of the system, whether the system is stable or unstable. Let's say the system is like this. Let's say this is the system. Now in this case, you can't calculate the Laplace transform. You can't take the Laplace transform. This is non-linear system because it is in the division. There is a division with xt. So you can't take Laplace transform. So problem is this system is non-linear. Why you need to take Laplace transform? You can check Bebo stability here. Is it fine? You can take xt as bounded. You can take xt as 0 and look at the output yt. If yt is also bounded, then the system is stable. Otherwise, the system is not stable. So you have to be selective where to apply which method. Okay. So I hope you understood it. What is the meaning of stable and unstable system? Okay. I'll take some more questions. Now let's come to invertible and non-invertible system. Now this is interesting, guys. Invertible and non-invertible. Invertible and non-invertible. Invertible and non-invertible. Let's look at this. Invertible and non-invertible. What is the meaning of invertible and non-invertible system? Invertible means, let's say you have a system. Let's say you have a system. In this system, you provided some input. Let's say you have provided xt or xn you have provided. Let's say this is the discrete time system. And the output is yn. And the output is yn. Is it fine? The output is yn. Now, if there is some other system which exists such that if you provide this output of the first system as the input, there is some system, in that system if you are providing this, the output of the first system, and you are getting xn again, it means what this system is doing, this system is inverting the operation which this system has done it. Let's say this system is doing some operation. Let's say this system is doing some operation. What it does is, whatever you provided input, it will provide you some output. It has done some operation on xn. Now what this system is doing, this system is inverting that operation and again finding the input. Then we call this system as the inverse of this system. Is it fine? Then I call that the system 2 is the inverse of system 1. And this system 1 is invertible. The system 1 is invertible and this is the inverse system. I hope it is clear to everyone. It means what I told you is, there is some system, you have provided some input, you'll get some output. Okay. If somehow there exists a system which can invert that output again to input, I mean from that output you can uniquely determine this input xn. If there exists a system like this which can take this output and uniquely it can determine the input xn, then I call that system as invertible, this system as invertible system, and this is the inverse of this system. Is it fine, guys? Have you understood it? Say yes or no. Tell me, guys, have you understood it? Say yes or no. Tell me, everyone. I hope it is clear to everyone. Now the word uniquely is very important. Okay, let's say there is a system yt equal to x square t. Is it invertible? Is it invertible? Let's check. What this system is doing, it is taking square of the input. Let's say you put xt equal to 2. So what this system will do, the system will take square of that. So output will be 4. Fine? Output will be 4 because it is taking square of this. So you'll get output as 4. Now, can there be a system which exists which can take this output and provide the input again? Tell me, guys. Yes, you can take yt equal to root of xt. This is the system. Yt equal to root of xt. If you take the root of this, then you will get the 2, no? No, sir. The problem is, if you take the root of this, let's say you are getting this output. Now this output will act as the input of this system. If you provide 4 to this system, then output of this system is plus minus 2. From this output, you can't uniquely say that this output came from plus 2 or minus 2. The problem is this. That's why if you think that the square root function is a inverse of this system. This is not true, guys. Okay, this system is taking square of that, whatever the input is, this system is taking square of that, and whatever the input is, this system is taking root of that. So if you think that sir, it will be this system will be inverse of this system, no sir. Problem is, let's say you take 2 input, it will make you 4. Now from this 4, if you take the root, you will get plus minus 2. It means you cannot uniquely determine the input. That's why you'll say that this system is non-invertible. This is non-invertible. Okay, you can't invert this. Okay, you will not get the invertible system for this. So this is non-invertible. Now let me tell you one more point. If any system, if there is a system, and in that system, if output came out to be 0, for some finite input, if output came out to be 0 for some finite input, then that system will be non-invertible. If any system, if there is a system which give you 0 output for some finite input, 0 output for some finite input, then you can't invert it. Okay, because you can't trace from where this 0 came. Okay, let's say there is some system which will provide you, let's say I have provided some input xt and you'll get 0 here. Now I want to apply one more system so that from 0 you can get xt uniquely. No sir, you can't get it, because this system does not know this 0, where this 0 came, from what value this 0 came. Okay, from what input this 0 came, because now it is nil, 0. Okay, if something is nil, you can't, I mean, you can't judge from where this quantity becomes 0. Okay, from which input this becomes 0. Okay, so that's the main problem. For any system, if there is a 0 output for finite input, then that system will be non-invertible. Remember this point. Okay, let's take an example. Yt is equal to dxt by dt. Tell me guys, is it invertible or non-invertible? Tell me, is it invertible or non-invertible? Tell me everyone, is it invertible or non-invertible? Is it invertible or non-invertible? Tell me everyone, is it invertible or non-invertible? Tell me, is it invertible or non-invertible? Please reply. Is it invertible? Let's take a finite input, xt as 2. Then yt will be equal to derivative of 2 is 0. It means you are not listening, Naveen, you are not listening, you are just guessing the answer. Okay, you are not listening. Raghuram, you are not listening. Okay, you are not listening what I am saying. Now you can see that there is some finite input and the output is 0. You know that. I told you, if you provide some finite input and if the output came out to be 0, then you can't convert it back. Okay, so this system is non-invertible because you are getting 0 output for some finite input. Okay, after this 0, after getting this 0, you can't invert it. You can't say that this 0 came from 2 or 3 or 4. Okay, so that's why this is the main problem. That's why this system is non-invertible. The system is non-invertible. Is it fine, guys? Now let's take yt equal to integration of xt dt from 0 to t. Tell me guys, is it invertible or non-invertible? Is it invertible or non-invertible? Tell me everyone, is it invertible or non-invertible? 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 Tell me everyone. Answer is, this is invertible. This is invertible. You can inverse it. And the inverse system is derivative. Inverse system is derivative. Okay, this is the inverse system of this system. Okay, this is the inverse of this system. But inverse of this system does not exist. Okay, this is non-invertible. You can't say that the integrator will be the inverse of differentiator. No. Because let's say you provide some constant input, you will get 0 output. Now from the zero output, you can't say that looking at the zero output only, you can't say that this zero came from 2 input or xt equal to 3 input. You are not sure. Because if the input is 3, then again you will get 0 output. If input is 2, then again you will get 0 output. So just by looking at the output, you can't say that this 0 came from 2 or 3 or 4 or 5. Okay, this is the problem here in this case. That's why it's not invertible. But this is invertible. Why? This is invertible. Why? Because in integration, if you integrate something and you want to look at from where this, if there is a system in which the output is integration of xt, then whatever the output is, you can take the differentiation of that and you will get the input value. It means, let's say this is the system, whatever input is, this system is taking integration. The system is taking integration. So now if you want to calculate, let's say you are getting this output here. From this output, you want to get this uniquely. So what you can do is you can apply a differentiator here. You can apply a differentiator and you will get xt as output. Okay, so you can say that this is invertible, but this is not invertible. Remember this point. Okay, I hope it is clear to everyone. Let's proceed. Let's take some questions and then I want to conclude this. Okay, let's take some question. I have yn equal to nxn. Tell me guys whether it is invertible or non-invertible. Yn is equal to nxn. Tell me whether it is invertible or non-invertible. The next thing is let's take yn equal to, let's take one more example. Let's say yn equal to x of n minus 1 for n greater than equal to 1, 0 for n equal to 0, and xn for n equal to less than equal to minus 1. Okay, this is the expression guys. Now tell me whether this is invertible or non-invertible. Tell me whether this is invertible or non-invertible. And tell me about the first one, invertible or non-invertible. The first one, tell me everyone, the first one. Let me take one more example. Okay, I can take one more example as yn equal to x of 2n. Yn equal to x of 2n. Tell me whether it is invertible or non-invertible. Okay, do it fast guys. Third one and the fourth one, yt equal to cos of xt. Whether it is invertible or non-invertible. We need to check these functions. Now first of all, this function. I want to look at this function. Okay, I want to look at this function. Now tell me whether it is invertible or non-invertible guys. Is it invertible or non-invertible? The first one, tell me everyone. Manoj Kumar, yes means, I need answer. What is the meaning of yes? Tell me what is the answer. Whether it is invertible or non-invertible. Okay, you are saying invertible. Okay, I don't think so. I don't think that this is invertible. Okay, why? Let's give it a finite input. Let's say xn is delta n. Xn is delta n. I provided finite input. Delta n is like this. One height is there. Okay, finite input. Now what is the output? Yn is equal to n delta n, and n delta n came out to be 0. N delta n value is 0. So for finite input it is giving 0 output. Tell me guys, for finite input it is giving 0 output. That's why this system is non-invertible. Non-invertible. Now before this 2, come to question number 3. Tell me about question number 3. I'll come to 2 maybe after solving 2 and 4, 3 and 4, then I'll solve question number 2. But before that, please tell me about question number 3. Whether it is invertible or non-invertible. Tell me guys, question number 3. Whether this is invertible or non-invertible. Tell me whether it is invertible or non-invertible. Is it invertible or non-invertible? Tell me everyone. Lokesh is saying invertible. Okay. Anyone else? Anyone else? Tell me guys whether it is invertible or non-invertible. Tell me everyone, you are not replying. Okay, this is again non-invertible. Why it is non-invertible? Why it is non-invertible? Because let's say input is like this. Let's say input is like this, 0, 1, 2. What is output, guys? Output is the scaled version of the input. If you are scaling this input by factor 2, then you can say this every point will be divided by 2. This will be the output, and you can say that this will be eliminated. This sample will be eliminated. So it means corresponding to this sample you are getting 0 output because this sample is eliminated. So just by looking at the output, since the sample has decreased, in the output some sample has gone. Now you can see that I told you, if something has gone, then you can't say the original value. You can't calculate the original value from that system. Okay, this is the main problem, guys. That's why this is non-invertible. Now tell me about question number 4. Tell me about 4, whether it is invertible or non-invertible. Tell me everyone, whether it is invertible or non-invertible. Tell me guys, whether it is invertible or non-invertible. Yt equal to cos of xt. Whether it is invertible or non-invertible. Question number 4. Tell me everyone, do it fast. Whether it is invertible or non-invertible. And do like the session. Those students who haven't liked it, please like the session. It is important, guys, because we have to make the century of likes. Anyway, so please like the session. Yeah, tell me guys, this is again non-invertible. Why it is non-invertible? Tell me. Why it is non-invertible? Because if you put xt as pi by 2, let's say, if xt is pi by 2, then yt will be 0. So for finite input you are getting 0 output. If for finite input you are getting 0 output, then the system will be non-invertible. Okay, then the system will be non-invertible. So remember this point. So I told you how to check the inverse system. Okay, how to check the inverse system of any system. If input output relation are given to you, if input output relation is given to you, then you can check whether the system is invertible or non-invertible. Now let's come to this. Now tell me, is it invertible or non-invertible? Is it invertible or non-invertible? Yes, it is invertible. It is invertible. Why? Why it is invertible? You can see that. Output is equal to, wait a minute, let's see, let's come to the next slide. Yt is equal to, let's come to the next slide. Yes, yn is equal to, what is yn? Yn is equal to x of n minus 1, for n greater than equal to 1, and 0 for n equal to 0, and xn for n less than equal to minus 1. Okay, this is the system. This relation is provided to you. Now I want to check whether the system is invertible or non-invertible. Now how to check? Tell me guys, how to check whether the system is invertible or non-invertible? Tell me. Now in this system, what we can do is, we can take some input, let's say xn. Xn is maybe let's say 4 delta n plus 2 delta n minus 1 plus 3 delta n plus 1. Let's take an input like this, random input I have taken. The input exists at 0 also, at n equal to 1 also, at n equal to minus 1 also. Okay, so this is the input I have. Now tell me the output. The output will be, if I want to plot the output, what will be the output? 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3. If you want to plot the output, then what will be the output, guys? For n greater than 1, or 1 or greater than, for this value, for n greater than equal to 1, if you want to plot in this range, then in this range output will be delayed version of the input. So you have to delay it. So if I want to delay it, x of n minus 1 will be 4 delta n minus 1 plus 2 delta n minus 2 plus 3 delta n. Okay, this will be the output for n. This will be the output, guys. This will be the output. Okay, and I have to plot from 1 onward. I have to plot this output for 1 onward. For 1 onwards, I have to plot this output. But remember, if you look at this output carefully, I mean this part, for n greater than equal to 1, output has to be x of n minus 1. So it means I have to plot the output yn for n greater than equal to 1. After 1, I have to plot. If you want to plot after 1, then output has to be x of n minus 1. X of n minus 1 is this. In this case, if I want to plot this x of n minus 1, I cannot take this. Why? Because the problem is this function exists at n equal to 0 and I want to plot yn for n greater than equal to 1. So if I want to plot it, it will be, tell me guys, it will be at 1 you have 4, at 1 you have 4, at 2 you have 2, at 2 you have 2, okay? You have to plot like this. This is gone. You can't write this. In output, you can't plot this 3 delta n because you are plotting for n greater than equal to. At n equal to 0, the output has to be 0. At n equal to 0, the output has to be 0. Is it fine, guys? Now for n less than minus 1, if you want to write less than equal to minus 1, then whatever the input is, you have to plot that only. For n less than minus 1, you can see that this is the only input. The input for n less than equal to minus 1, whatever the input is, that will be the output. Now if you look at the input value, this is my input. Let me plot the input also. The input is 2 here and sorry 4 at n equal to 0 it is 4. Let me plot the input. This is 4, this is 2 here at 1 and 3 here at minus 1. Minus 1 you have 3, okay? So this is my input xn. Now the output for n less than minus 1, n less than equal to minus 1, the output is same as xn. For n less than minus 1, from this point onward, minus 1 point onward, whatever the input is, the same will be the output. So at this point you have to show the 3 only, okay? You have to show the 3 only. Whatever the input value is, for n less than equal to minus 1, whatever the input is, the same will be the output. So this will be the output. Now you can see that the output will appear like this. This delta n will disappear, this n equal to 0 value. For this point n equal to 0 value, at this point you can see that for this value n equal to 0 value, for this delta, let's say the input value is this only. Let's say this is the input only. Let's say the input value is this only, 4 delta n. So input exists at 0 point only and the value is 4. Now tell me what will be the output. For n greater than equal to 1, output should be x of n minus 1. So if you take output as x of n minus 1 for n greater than equal to 1, then you can say x of n minus 1 is 4 delta n minus 1. So this will become 4, okay? At n equal to 0, output has to be 0, and at n less than minus 1, output has to be 4 n minus, output has to be 0 again. Wait a minute, let me explain it again, because now I hope that everyone is confused. Okay, let's try it again. Let's try it from the beginning. So what I'm doing is I'm plotting the yn. Okay, I'm plotting the yn for xn. Let's say xn is provided to you. Okay, xn is provided to you. And xn is like this. I'm plotting the xn. So xn is like this. This is my 4. Let's say this is 4. This is 2. And let's say this is also, this is 3. This is 3. Okay. So now what I want to do is, I want to plot the yt. I want to plot the yn. Now what is the yn? 0, 1, 2, 3, 4, 5. This is -1, this is -2, this is -3. I need to plot yn. Tell me guys, what should be the yn? What should be the yn? Tell me guys, what should be the yn? Yn has to be x of n minus 1 for n greater than equal to 1. It means if you are plotting yn for 1 or 1 onward, then whatever the xn is, you have to delay it. If I delay it, I'll get the value like this. X of n minus 1 will be like this. It will be 3 here, here it will be 4, here it will be 2, okay? 0, 1, 2, and then 0, 0. This is my x of n minus 1. It means yn has to be equal to x of n minus 1, but you have to show it for n greater than equal to 1 only. For n greater than equal to 1 only, you have to show whatever x of n minus 1 is, that will be equal to yn. So for n greater than equal to 1, if you look at n greater than equal to 1, this is x of n minus 1. This represents x of n minus 1. So yn has to be this, okay? At this point, you have to have 4, and then it should be 2 here, okay? Yn will be like this. Is it fine? Is it fine? Now, for n equal to 0, output has to be 0. For n equal to 0, output has to be 0. I have shown output as 0. From this output, tell me guys, can you get the input uniquely from this output? Tell me everyone. Why it is buffering? Wait a minute. I think it is clear now. Is it clear? Tell me. Okay, now tell me, from this output, can you get this input uniquely? Can you get this input uniquely? Tell me guys. Tell me everyone. Is it buffering now? Okay. So tell me, from this output, can you get this input uniquely? Can you get this input uniquely? What we can do is, let's try to take it inverse. And the inverse will be like this. Let's say we have one more system in which the output is y1. There is one more system which is the inverse of this system. Now, how I am taking inverse is like this. Since for n greater than equal to 1, what we have done is, for n greater than equal to 1, the first system is delaying the input. For n greater than equal to 1, the first system is delaying the input. So what you can do is, you can advance the input, x of n plus 1. Is it fine guys? Is it fine? Tell me. So for n greater than equal to 1, what you can do is, you can advance the input. Now, 0 for n equal to 0, and xn for n equal to n less than equal to minus 1. Let's take, this is second system. This is my second system. If it is delaying, I have taken the advancement. At n equal to 0, yn was 0, so I have taken yn 0 here also. And for n less than minus 1, this was xn, so I have taken xn only. Let's say that this is the inverse of this system. Let's assume that, because whatever operation this system is doing, I am taking the inverse of that. If it is delaying, I'm further advancing the system. Okay. Now in this system, this is the input x1n, because the output of the first system will act as an input of the next system. Okay, this output will act as the input of this system. Is it fine? Is it fine? Now you can check from this. Now this is x1n. I need to plot y1n now. Let me plot y1n. Let me plot y1n now. Now this is x1n guys. For this system, for n greater than equal to 1, 0, 1, 2, 3, 4. Okay, let's see. For n greater than equal to 1, it means 1 and more than 1, y1n is x1n plus 1. It means whatever this x1n is, you have to take it back. You have to advance it and you have to plot it. If you are taking advancement of this, then this will become at 0. So we will not look at this 4 sample. Why? Because it has become to 0. It has gone to 0 value. x1n plus 1 will be the advancement of this. So this 2 sample will come at 1. So I have to show this 2 sample. Is it fine? Because I am showing for n greater than equal to 1 only. If you are showing for greater than equal to 1 only, then this 2 sample will come at 1. Fine. And at n equal to 0, it has to be 0. N equal to 0, it has to be 0. And at n equal to minus 1, whatever x1 and x2n is, whatever x1n is, the same will be y1n. x1n at n equal to minus 1 is 3. So you can say that here the value is 3. So this will be my output of this system. Now you can see that one value is gone. Which value? N equal to 0 value. So original input was this. If I take an inverse of that, if I take the inverse operation of that, I will not get this 0 value. I will not get this n equal to 0 value. At n equal to 0, originally it was 4, but now it is 0 here. Okay, this is the problem, guys. This is the problem. That's why I call it non-invertible. I call it non-invertible. Is it fine, guys? I don't know how many of you have understood it, but anyway, if you have not understood it, you can leave it, because these are the typical questions. Anyway, let's come to the next. So I told you about the invertible and non-invertible system. Let's take one more example. Yt equal to x of 2t. I have taken yt equal to x of 2t. Yes. Tell me, guys, yt equal to x of 2t. I have taken yn equal to x of 2n. That is non-invertible. Now I am taking yt equal to x of 2t. Tell me, everyone, whether it is invertible or non-invertible. Tell me. Yt is equal to x of 2t. Yt equal to x of 2t. Tell me whether it is invertible or non-invertible. Yn equal to x of 2n was non-invertible. I have told you why. Because one sample is gone. The sample which are present at the odd value of n, those sample will become 0. But if you take yt equal to x of 2t, tell me, guys, whether it is invertible or non-invertible. Do it fast. Do it fast, guys. Tell me yt equal to x of 2t, whether it is invertible or non-invertible. Tell me whether it is invertible or non-invertible. I did a mistake here. It should be invertible. Why? It should be invertible. Answer is invertible. Why? You don't take this type of system. Okay? What you can do is, because you know that this zero sample has advanced to 1. In the original system, this zero sample, n equal to 0 point, has advanced to 1. So what you can do is, you can take y1 as x1 n plus 1 for n less than equal to 0, not less than, greater than equal to 0. Okay, greater than equal to 0. Don't take it greater than equal to 1. Take it greater than equal to 0. Why? I'll tell you. And then x1n for less than equal to minus 1. You can take the system like this. This way you can get this 0 sample also. How? Look, this is my x1n. Now the output y1n will be x1n plus 1 for n greater than equal to 0. So if you take x1n plus 1, what is x1n plus 1, guys? You have to take it back. x1n plus 1 will look like this. 4, this will be 2, and this will be 0, and this will be 3. This will be x1n plus 1. Now x1n plus 1, I have to take y1n must be equal to x1n plus 1 for n greater than equal to 0. It means for n greater than equal to 0, if you want to plot y1n, for n greater than equal to 0, you have to write this. So it should be 4 here and 2 here. Okay? Because for 0 and 1, you can plot y1n. For 0 and 1 or n greater than equal to 0, whatever x1n plus 1, the same will be y1n. So for 0 and or maybe greater than equal to 0, you can see that this is my x1n plus 1. So whatever x1n plus 1, you have to take at y1n. Okay, so I have shown it like this. Now for minus 1, you can say it is equal to x1n. So x1n is this, and for minus 1 it is 3, so it will also be 3. So you can see that you can actually uniquely trace this input. Okay, that's why this is invertible. Please do it correct. Okay, this is invertible. Please do it correct, guys. This is invertible. This is not non-invertible. This is actually invertible. Okay, so sorry from my side. Anyway, let's come back to this. Tell me about this system. Yt equal to x of 2t, whether it is invertible or non-invertible. It is invertible. It is invertible. Why? Because if it is scaling by 2 factor, then you can take one more system which is scaling by half factor. It means, let's say there is one system. What this system does is, whatever input you provide, it gives you x of 2t, scale by 2. Now you can cascade one more system which take half of it. I mean, for this system, yt is equal to x of t by 2. It means whatever input you are providing, it will scale by half. If it is scaling by half, then output will again become xt. Uniquely you can get the output. So that's why this system is invertible. This system is invertible. Okay, is it fine, guys? Yes, we can design. There is no problem. So I told you that this system is invertible, but this is non-invertible. Because in discrete time, if you take the scale by 2, if you are scaling the system by 2, then there will be some sample which will be gone away, which will become 0. If you don't know about those samples, then you can't retrace them, you can't recover them. Okay, so this is the main problem. But in this continuous time domain, nothing is gone. Okay, if you are going to scale it, everything will remain intact in the signal. Only thing is the signal will be compressed by 2 factor. So what you can do is you can further elongate it, then you can scale it by 1/2. Okay, you'll get the same answer. I hope you understood it. Okay, so I told you about this type. I told you about this type. I told you about these types, linear, non-linear, time variant, invariant, and everything I told you. Now I want to ask you some problem. Let's say the first problem is, let me add some slide and then ask you about some statement. Please tell me. Wait a minute. Let me add some slide. Let me add some slide. Okay, now what I want to ask you is, please answer me the first question. The first question is, if system is causal, it will be static. True or false? If system is static, it will be causal. Tell me which statement is true. Tell me which statement is true. If system is causal, it will be static. If system is static, it will be causal. Now tell me which statement is correct. Tell me, everyone, which statement is correct. Tell me which statement is correct. Do it fast, guys. If system is causal, it will be static. If system is static, it will be causal. Answer is the second one. The second one is correct. If the system is static, it means it depends on the present. The present output depends on the present value itself. So it will be causal, because the output depends on the present input only. In causal system, present output depends on either present value or present plus past value or past value. Now static is the domain of, static lie in the domain of this causal system. So you can say that if any system is static, it will be causal everywhere. It will be causal for sure. Now the third statement. If system is dynamic, it will be non-causal. It will be causal. Let's take it causal first. And then number 4, if system is dynamic, it will be non-causal. Now tell me, out of these 4 statements, second one is correct, that's for sure. What about other 2? First one is wrong, that's for sure. Second one is correct. What about the other 2? Tell me. The third and the fourth. Which one is correct? If system is dynamic, it will be causal. If system is dynamic, it will be non-causal. It will be causal. It will be non-causal. Now tell me which statement is correct out of 3 and 4. Sir, but how statement 1 is not correct? Okay, let me tell you guys. If the system is causal, it may depends on the past value. Present output depends on the past value. Let's say yt is equal to xt plus x of t minus 1. Now you can see that this is the causal system. If you look at the t equal to 1, at t equal to 1, the output is at 1, and the input is at 1 also, and there is one more input at 0. Okay, so you can say that the present output depends on the present input and the past input. So it is a causal system, but it is not static. Why? Because of the past value, it is not static. So you can't say that a causal system is static, but a static system will always be causal. That's correct. Because in static system, present output depends on the present input. It means let's say you are taking output at t equal to 1. So I have to provide the input at t equal to 1 itself. Okay. And present output depends on the present input, then it will be causal. Okay. This is the definition of causal. In causal system, present output depends on either on the present value or present plus past value or only the past value. So there can be 3 possibilities in causal system, but there should not be any future term. Okay. In causal system, there should not be any future term. It can depend on only present value or present plus past value. The present output can depend only on the present value or present plus past value or only the past value. Then it will be causal. But in static system, we know that the present output depends on the present value itself. So it will also be a causal system. Okay. I hope you understood it. Now let's come to this 3 and 4. Tell me guys, which statement is correct? Is there any statement which is correct in 3 and 4? Tell me, is there any statement which is correct in 3 and 4? Tell me everyone. Is there any statement which is correct between 3 and 4? Between 3 and 4, which statement is correct? Everyone tell me. Please tell me everyone. Both are wrong. Yes, both are wrong. Both are wrong. If system is dynamic, it will be causal. If system is dynamic, it will be causal. No, sir. Dynamic can depend on the future value. The future will also tell you the dynamic nature. Okay, so it will not be causal. If the system is dynamic, it will be non-causal. No, sir. Dynamic can depend on the present and the past. If the present output depends on the present and the past value, then it is dynamic for sure, but it will not be causal. Okay, so you can say that both the statements are wrong, only 2 is correct. I hope it is clear to everyone. Now let's come to the LTI system. I want to teach you about LTI system. What is the meaning of LTI system? Let's discuss about LTI system. Linear time invariant system. I want to discuss about LTI system. I'll take only half an hour. Okay, maybe at 2:40 or 2:30 I'll stop the class. So let's come to LTI system, guys. What is LTI system? LTI means linear time invariant system. Okay, LTI means linear time invariant system. If a system is linear and time invariant, then we call that system as LTI. And in LTI system, there is a interesting characteristic. What is that interesting characteristics? For an LTI system, if you know the output for an LTI system, if you know the output yt for some input xt, if you know the output yt for some input xt in LTI system, if you know the output for some input xt, then you can calculate output for some other input. You can calculate output for some other input, no problem at all. Okay, let me repeat this. In an LTI system, there is one important property it carry. Okay, and what is that property? If you know some output for some particular input, let's say, then you can calculate the output for some different input. This is the beautiful behavior of this LTI system. Okay. Now in LTI system we define impulse response. We define a term impulse response. Impulse response. Let me tell you guys, impulse response can be defined for non-LTI also. Because of this, its meaning. Let me tell you what is the meaning of this impulse response. Now, what is the meaning of this impulse response? Impulse response means if you are providing impulse input, then what is the response here? We call it impulse response. Let's say the impulse response of system is HT. What is the meaning of it? The meaning of it is if you are providing impulse input, then the output will be HT. If impulse response is provided to you, let's say impulse response is this, it means the response of the impulse is this. If you're providing impulse as input, then the output will be HT. If you know the impulse response of this system, if you know the impulse response of LTI system, then you can calculate the response of some other input directly. This is the property of LTI system only. Let's say you know the impulse response of system. One more thing, impulse response can be defined for non-LTI also. Let's say you have a system yt is equal to, maybe yt equal to 2xt plus 2. Tell me about this system, whether it is LTI or not, whether it is linear or not. Tell me guys, first of all, tell me whether it is linear or no linear. Tell me everyone, is it linear or no linear? Is it linear or no linear? Tell me everyone. Obviously it is non linear. Because of this constant term, it is non linear. Now, if you want to calculate the impulse response, you can put xt as impulse, no? Input as impulse, delta t. So the impulse response will be 2 delta t plus 2. Fine. So you can see that impulse response can be defined for linear as well as non-linear system. Impulse response can be defined for linear as well as, LTI or non-LTI system. What you need to do is you need to plot, put xt equal to delta t. That's all. And you can calculate the output yt. You can calculate the response for that. Okay. So if you put xt as impulse, then you'll get impulse response, yt as ht. Okay. Because it is the impulse response. So you can see that for non-LTI system also, impulse response is defined. But in LTI system, there is a beautiful behavior. And that beautiful behavior is, if the impulse response of LTI system is provided to you, then what you can do is, you can calculate the response of some other input. And how to calculate that? Using convolution. Obviously, I'm not going to tell you the proof. But if you know the impulse response of LTI system, then for some other input, let's say xt, output will be xt convolution ht. Using the convolution, you can calculate the output yt. Okay. It means the convolution is applicable only on linear system, only on LTI system. The convolution is applicable only on LTI system. It is defined for LTI system. For LTI system, if you know the impulse response, then you can calculate the output for some different input xt using the convolution. It means the convolution is applicable only on LTI system. Convolution means LTI. Remember this point. Now, let me tell you one more point. And that point is how to write this. This can be written as from minus infinity to infinity x of tau h of t minus tau d tau. Or you can also say that you can say h of tau x of t minus tau d tau. In any term you can put tau value. In place of t you put tau, and in place of t you can put t minus tau, and you can solve it. So if you don't know how to calculate the Laplace, how to do the convolution in time domain, you can use Laplace transform or Z transform. Using the Z transform also you can calculate the convolution. Okay. Using Z transform you can calculate the convolution. There is no problem at all. Okay. So be careful guys. In discrete time domain, let's say yn is equal to, for an LTI system, in discrete time system, let's say impulse response is defined. For delta n, hn is provided to you for an LTI system. Now what you can do is, you can take any input xn. For that input xn, output will be xn convolution hn. This way you can calculate the output due to some random input in an LTI system. Okay. Now how to write this convolution? In discrete system, the convolution can be written as x of tau h of n minus tau tau from minus infinity to infinity. In place of integration, you have summation here. Okay, you can also write it h of tau, x of n minus tau. There is no problem at all. Okay, you'll get the same answer. So I told you how the convolution works, and convolution is defined only for LTI system. Remember this point. For non-LTI, you can't say that. Now, since I told you that x of tau or h of tau, you can write this x of tau or h of t minus tau or h of tau t minus tau, both will give you the same answer. Now from this I can say that xt convolution ht is equal to ht convolution xt. Okay, from this relation I can say that xt convolution ht equal to ht convolution xt. It means you can interchange input and impulse response. You can assume this impulse response as input and input as impulse response in LTI system. There will be no problem with the output. Output will remain same. Okay, so you have to be careful. Let's say tell me guys, is it working now? Is it working now? Okay, I think it is working now. Tell me, is it working now? I think it is working now. Okay, perfect. Now look at this. Let's come back to this topic. Now I told you, let's say for an LTI system, if impulse response is provided to you, what is the meaning of this? Meaning of this is, if you provide as input as an impulse as an input, if you are providing impulse as an input, then the response of that impulse is this. If input is delta t, the response will be this. It means you can say that yt is equal to delta t convolution e to the power minus 2t ut. You can write like this because you know that the output is the convolution of xt and ht. So if impulse response is provided to you, what is the meaning of it? It means this is the response of the impulse. So you can take xt as delta t. If you take xt as delta t, then the response will be ht, or you can say yt. So what you can say is, now the yt will be xt convolution ht. We know that. We already know that yt is equal to xt in LTI system. This is true. And xt is delta t and ht is this. So the output has to be impulse. Output has to be impulse response. Is it fine, guys? I can write it like this. Tell me, is it correct or not? Let me repeat this again. We know that this is the impulse response. So if I put input as impulse response, input as impulse, then the output will be impulse response itself. You'll get this as output. And we know that yt is equal to, in LTI system, yt is equal to xt convolution ht. Xt convolution ht. So if xt is impulse itself, if I take xt as impulse itself, then yt will be impulse response only. Is it fine? Is it fine, guys? So remember, whenever some function is convolved with delta t, you'll get the same answer. You'll get the same answer. Okay? Whenever some function is convolved with delta t or delta n in discrete you take delta n here, you'll get the same answer. Is it fine? Now let's say input is, let's say hn is provided to you. Let's say this is my LTI system, and in LTI system ht is provided to you. Ht is the impulse response. Now I give the input as t minus 1. What is the output, guys? What is the output? For delta t input, output is ht. For delta t minus 1, output has to be t minus 1, because the system is time invariant. So if you are delaying the input, output will also get delayed by the same factor. Okay? So you can say that from this relation, I can say that delta t minus t naught convolution ht will be equal to h of t minus t naught. You can treat this as input and this is impulse response. So response of the impulse is this. But now I have put the delayed input as input, delayed impulse as input. Okay, delayed impulse as input. So if the impulse is delayed, then the output will also get delayed, because the input is impulse again. I have taken impulse input again, but it's a delayed input. So the output will also get delayed, because we know that from delta t you will get ht, so delta t minus 1 you will get ht minus 1, so it's delayed also. Okay, so remember these are the properties of impulse, these are the properties of convolution. Now what you can say is, let's take one more case, delta at plus b convolution ht. Tell me what will be the value. What will be the value, guys? What will be the value? So first you simplify this. If you simplify it, it will be 1 upon a mod del of t plus b by a convolution ht. Now what you can do is, so answer will be 1 upon a mod h of t plus b by a. Simple. Okay, so remember, whenever whenever impulse is convolved with some other function, you'll get the same answer. You'll get the same ht. But if delayed impulse is convolved with some other function, then this function will also get delayed by the same number. Okay, by the same factor. So I hope you understood it. So these are the properties of impulse. Okay, these are the properties of impulse. You have to remember like this. Okay. These are the properties of convolution, I told you, and convolution is applicable only for LTI system. Impulse response can be defined for every type of system, but convolution is not defined for every type of system. Okay, so you have to be careful. Now again, this is applicable for discrete time system also. Okay, this is applicable for discrete time system also. Now what we can do is, let's say I want to check about the stability. Number 2, causality and static and dynamic nature of the system. You can also tell these three things with the help of HT. With the help of HT, you can tell us about the stability of the system, or the causality of the system, or static and dynamic nature of the system. How? For stability, what you need to do is to take the mode of this. I'm not telling you the proof. Okay, if it is finite, mode of ht from minus infinity to infinity, if ht is provided to you, if impulse response is provided to you for linear system, okay, I'm telling you for LTI system. For LTI system, if ht is provided to you, you can check the stability like this. Okay, this is the rule for the stability. You can check the stability like this. Okay, similarly you can check the causality. How to check the causality? If ht is equal to 0 for t less than 0 and ht is not equal to 0 for t greater than equal to 0. Okay, we call it causal system. Causal system means ht does not exist for negative time. We call it causal system. Remember this point. With the help of ht, you can tell us about the causality also. Let's say there are some system in which input and output relation is not provided. If input and output relation is provided, you can easily tell us about the causality. Okay, you can tell us about whether the system is causal or non-causal. Okay, but the problem is, let's say ht is provided to you. Using ht also, if the system is LTI, if the system is linear time invariant, then only you can comment on the causality. How to check the causality? You can say like this: if ht is 0 for negative time and it is not 0 for, I mean the ht exists for positive time only, we call it causal system. Now let's come to static and dynamic system. If ht is of this type, k delta t type, if ht is of this type, then we say that the system is causal, the system is static. Then we say that the system is static. It's a static system. Okay, it's a static system. Otherwise it is dynamic. K can be positive or negative number. Okay, k can be of positive or negative number. So if ht is of this type, we call it static system. In discrete time domain also, these things will remain same. Only the integration will be replaced with summation, and ht will be replaced with hn. T can be replaced with n. Okay, so I told you how to check stability, causality and static and dynamic nature using ht, impulse response. Let me give you an example. Let's say ht is equal to e to the power minus 2t ut. Tell me about all these three things, and given that the system is LTI, if the system is LTI, tell me about the stability, causality and static and dynamic nature. Tell me guys, whether it is stable or not. Say yes or no. Tell me whether this system is stable or not. Is this system stable or not? Tell me, guys. Tell me whether this system is stable or not. Static system, when yes, it is not static, because HT is not of this type, K delta T. HT is not of this type. That's why this is not static. This is dynamic. That's correct. This is dynamic. Okay. Dynamic. Anyway, so this is dynamic. Now, is it causal? Tell me, guys. Is it causal or non-causal? Tell me. Now you can see that UT is attached with this. If UT is attached with this, it means it is defined only for positive time. If it is defined for positive time only, it means it's a causal system. It's a causal system. It's a causal system. Okay. So it's dynamic causal. Now, please tell us about the stable. Yes, it is stable. What you can do is you can calculate the area of this system. You have to take mode of this system first. Since it is already positive, so you don't need to take mode. It is e to the power minus 2t and ut is attached there. So ut means it is from 0 onwards. So you start integrating from 0 to infinity dt. So this answer came out to be 1 by 2. It's finite. Okay. Answer is finite. Okay. So you can say that this is stable also. This is stable also. Is it fine, guys? This is stable. Let's take one more question. There is an LTI system. There is an LTI system whose HT is provided to you. There is an LTI system whose HT is provided to you. Okay. And then HT is given as e to the power minus 2t u of minus t plus 1. Okay. Now tell me whether it is stable or not, causal or not, static or not. Tell me, guys. First of all, tell me about the stability, whether it is stable or not. Tell me whether it is stable or not. Tell me whether the system is stable or not. You can apply the same concept of discrete. Tell me, everyone, whether the system is stable or not. Answer is unstable. Unstable. No, this is not stable. Why? This is not stable. Why? Because the system starts from 1 and it will be increasing like this. So you have to take the area of this function. So area will be from minus infinity to 1, because this function exists between minus infinity to 1, because there is u of minus t plus 1. It is multiplied with u of minus t plus 1. It means this function is on the left sided. This function is on the left sided and it starts from 1. Okay. So it will be e to the power minus 2t dt. If you calculate this area will be infinite. Up to infinity, this area will be infinite. It is not finite. That's why it's unstable. Now tell me about causal or non-causal. Again, it's non-causal. Why? Because it exists in negative side. That's why it's non-causal. Okay. That's why it's non-causal. Now let's come to static or dynamic. It is dynamic. It is not of k delta t type. If it is not of k delta t or k delta n type, you can't say that it is static. So it's dynamic. Is it fine, guys? So if there is an LTI system and if ST is provided to you, you can comment on stability, causality and static and dynamic nature. Okay. I hope it is clear to everyone. Now let's come to the next thing. Now I want to tell you about the properties of the convolution. Okay. Let's take properties of the convolution. Let me add some slide. Okay. The properties of the convolution. Let's look at the properties of the convolution. Convolution properties. Obviously, you don't need to find the convolution using time domain analysis. Let's say you need to find this e to the power minus 2t ut convolution ut, or 1 by 2 raised to the power n un convolution un. Let's say you need to find this. Now how to find it? You don't need to apply, you don't need to solve this question in time domain. So you can solve this question in Z domain. Using Z transform you can solve it, and using Laplace transform you can solve it. Okay, so if you know the Laplace transform or Z transform, you can solve these questions using Z transform, and you can solve this question using Laplace transform. Okay, is it fine? Sir, anti-causal means only future na? Yes. Anti-causal means something which is only on the negative side. Anti-causal means if the system is anti-causal, it means it is purely on the left side. Okay, it purely depends on the future values. We call it anti-causal. So let's come to the causal convolution properties. I told you, if the convolution came into exam, let's say this question is asked, you don't need to solve it in time domain. Okay, you can solve this question in Laplace domain. There is no problem at all. You can solve it in Laplace domain. Why you'll apply this formula from minus infinity to infinity, x of tau, h of t minus tau, and d tau. It will be very lengthy. Okay, so it's not a good idea to solve using time domain. So you can solve this question in Laplace domain. Okay, now what I want to tell you is there are some properties which convolution follows. What are those properties? First of all, let's say you have a system, and system is LTI, and you know the impulse response. First, I have already told you this is xt and this is yt. We know that yt is equal to xt convolution ht. We know this. Yt is equal to xt convolution ht. Now what you can do is you can interchange. In an LTI system, you can interchange ht and xt. In place of xt you can take ht, and in place of xt you can take ht you can take xt. You'll get the same answer. No problem at all. So first of all, you have to remember this point. Okay, you can interchange the input and impulse response in a LTI system. Let's say there is e to the power minus 2t ut convolution delta t minus 2. We need to calculate this value. So what you can do is you can treat this function as impulse response and this as input. If the input is delta t, this will be the output. But since the input is not delta t, input is delta t minus 2, it's a delayed input. So what you can do is the output will be e to the power minus 2 t minus 2 u of t minus 2. You can delay the output. Okay, if the input is impulse delta t, then this will be the output. Now the input is delta t minus 2. I have treated this as input and this as impulse response. Now it's your choice. You can treat this as impulse response and this as input, or maybe some opposite way. Okay, I hope you understood this point. Okay, now this is the first property I told you. Let's come to the next property. The next property is, let's say there are two LTI system, and the impulse response is h1t here, and there is one more LTI system, and the impulse response is h2t, and they are cascaded. They are connected back to back. Now you can replace these two systems as a single system, and the impulse response of the single system is h1t convolution h2t. Okay, you can replace these two systems as a single system like this, h1t convolution h2t. Just remember it. Okay, this is again a very good property. So you can combine these two systems, you can convolve their impulse response in time domain, and you'll get the overall transfer function, the overall impulse response. Now you can also apply the Laplace transform. Let's say the transfer function of this system is h1s and the transfer function of this system is h2s, and if they are in cascade form, what you can do is you can combine them and make them h1s into h2s. Okay, so remember this point. You can cascade them, guys, and you can combine them. Now let me tell you one more point. Let's say the input is like this, -1 to 1, it is 1, and there is one more, there is impulse response, and impulse response is given like this. Let's say impulse response is this, -1 1, and this height is, let's say, 2. Okay, and you want to convolve them. So the answer will be from where it will start and from where it will end. We can check that. You can see that this start at -1 and this start at -1. So you can add the lower limit. If you add the lower limit, it will be -2. Means whatever the convolution you will get, whatever the answer you will get, it will start from -1. You can also add the upper limit. So if you add the upper limit, higher limit, then it will reach to 2. Okay. So the answer will exist between -2 to 2. I told you how to find it. I told you check the lower limit of this function and the lower limit of this function, and the upper limit of this function and the upper limit of this function. What you can do is you can add these lower limits and you can add these upper limits. Okay. So the resultant function will be from -2 to 2. Okay. This is the first point. The next point is whatever function you are getting, whatever output you will get, the area of this output, area of y, will be equal to area of input into area of impulse response. Area of input into area of impulse response. Okay. This is again the property of convolution. Just remember this. Okay. Whatever the answer is, whatever answer you are getting here, whatever shape you will get here, in that shape, our area, the total area will be equal to area of this function into area of this function. Now what is the area of this function? Area of this function is 2. Let's call it input ax, and area of this is again 1 by 2 into 2 into 2, that is 2. So the area of the convolution of these two functions will be 4. 2 into 2 is 4. Okay. If you convolve these two functions, if you convolve these two system, I mean this is system, this is signal. So if you convolve them, the resultant, whatever the shape of the resultant will be, the area will be product of these two. Okay. So the area will be 4. I hope you understood it. Okay. Now, okay. So these are some properties, guys, you have to remember. I mean, without plotting the shape, you can judge which, let's say there are 4 shapes are provided to you. So the shape which will satisfy these properties will be the correct shape. Okay. So you can check the options in which these conditions are satisfied, of the lower limit and the upper limit. Okay. And the total area of the function. In discrete time system, let's say we have xn and the length of xn is n1. The total sample, the number of samples in x1s are n1, and the number of samples in hn is n2. So if you can convolve them, xn convolution hn, the length will be n1 plus n2 minus 1. The entire length will be n1 plus n2 minus 1. But in continuous time, the length of this signal is L1, let's say, and the length of this signal is L2. So the length of this signal will be L1 plus L2. You can see that this length is 2, this length is also 2. If you add them, the length will be 4. This length has to be 4. But in discrete, you has to be add the number of samples. N1 is number of samples, N2 is also number of samples in Hn. So what you can do is, if you convolve them, the number of samples will be N1 plus N2 minus 1. This will be the number of samples. You can count the number of samples in discrete time domain. Okay. Again, in discrete time domain also, the lower point, you can add the lower point, lower sample location, and you will get the resultant. I mean, whatever the output is, in the output, the lower sample position you can get. You just have to add these two values. You will get the lower sample position, and you have to add these two values. You will get the upper sample value. Okay. So in discrete also this is true. I hope it is clear to everyone. Now what I can do is, now there are some good questions about the interconnection of the two networks. Okay. Interconnection of two systems. Interconnection of two systems. Okay. In last class also I told you about some question. If you remember, in last class I told you about some questions. Okay. So let's say there are two systems, system A and system B. There are two systems connected like this. There is a cascade connection. Okay. Okay guys, I'll take the class only for 10 minutes. I'll wind it up in 10 minutes. Okay. Let's say there are two systems connected like this. Now there are two systems connected like this, and the first system is, let's say, LTI, and the other one is also LTI. You can replace them with single system, and the single system will also be LTI. It will also be LTI. Remember this. System A system A and system B. If one system A is LTI and the system B is also LTI, then the resultant will be LTI. The resultant will be LTI. Now, let's say system A is non-LTI. System A and system B. System B. Let's say this is time variant. This is also time variant. Then the resultant of these two systems may be time invariant. It may be time invariant. It may not be time invariant. Okay, I told you in the previous class, I have given you the example also. You can see that, let's say one system is time variant. Time variant means one system is like this, yt is equal to x of 2t, and the next system is yt equal to x of half t. Okay, so what is the meaning of this? This system is scaling by 2 and this system is scaling by half. Both the system are time variant, they are not linear. Both the system are time variant. Okay, now if you have cascaded them, the overall system will be yt equal to xt. You get yt, and yt equal to xt will be an LTI, a time invariant system. So the cascading of two time variant system may be time invariant. Remember this. Okay. Now let's take system A as stable. Let's take system A as unstable system. System A and system B. If it is unstable and it is also unstable, then the resultant can be stable. Resultant may be stable. Okay, resultant may be stable. I told you the example in the previous class, pole zero cancellation, if you remember. Similarly, if there is a system A and system B, if system A is stable and this is unstable, then the combination will may be stable. It may be stable. Okay, the combination may be stable. I told you in the previous class, pole zero cancellation again. Okay, so remember these points, guys. There are 4 or 5 cases. I told you some. There are some two extra cases also. No? Let's say one system is let's say there is a combination of no linear system. Overall system may be linear. Okay, I told you system A and system B. If it is non-linear and this is also non-linear, the combination may be linear. Combination may be linear. Okay, remember this point. Okay, combination may be linear. I told you in the previous class. So these were the cases, guys. You have to remember it. Okay, sir, Fourier series. Okay, I'll take a dedicated session on Fourier series also because right now the class duration was only 2 hours and I have completed that duration. And I'm taking approximately, now I'm reaching 3 hours because I have started from 12 and it's going to be 3 p.m. now. So I have extended the time to 3 hours. So again, that's a problematic thing. So in 2 hours you can't complete the topics. No, that's why. That's the main reason. So no problem, guys. After the marathon session is over, I will take some dedicated session on the Fourier series, continuous time and discrete time, so that it will be covered and you can cover the topic from this. Okay, so that way you can remember the things. There are so many points about linear and non-linear system that I want to tell you, but the time does not allow me because I have one more session at 4 p.m. For power system. So I have to stop it here. Whatever things are left, I'll cover it because I have to cover the Fourier series part also, continuous time Fourier series, and then I have to take the properties of the Fourier series, and then I have to take the discrete time Fourier series also. So I will cover that part in some dedicated session. Okay, I will take some dedicated session for that, and in that session I will cover that. I hope you have understood the concept of system. Okay, and in system also there are some points that I want to tell you, but anyway, now it's not the time. We'll take one more session about that, and I'll tell you about the remaining part of the system and continuous time Fourier transform and discrete time Fourier, continuous time Fourier series and discrete time Fourier series. I'll cover that in some other session. Okay, so thank you for showing interest in this class, guys. Don't forget to attend the power system class, because in today's class in power system I'm going to cover the per unit system, and then I'll cover the load flow studies and the fault analysis. So I'll try to cover that part. I hope you'll enjoy that part also, and you'll understand some new concept in that part. Okay, so that's all for today's session, guys. I hope you enjoyed. Thank you, and see you in the next session, power system at 4 p.m. Okay, so thank you and take care. Periodic and non-periodic signals, sir. Periodic and non-periodic signals I have already covered in the last class. I have taken some example on periodic and aperiodic signals, so please check it. I have taken some questions. Via questions I have revised that. Okay, and in this session I have revised mainly the theory part. Okay, I have revised mainly the theory part, if you can see. So on system I have taken the class. Okay, so that's all for today's session, but don't forget to subscribe our channel and like this session, and make sure that you install our mobile app, because on mobile app also there are some revision classes which are going on. So you can join BYJU'S exam prep mobile app. Okay, there also you'll get some classes for the revision, and don't forget to subscribe. So that's all for today's session, guys. I hope you enjoyed today's session, and yes, in the next class I'll cover continuous time Fourier series, discrete time Fourier series, and if the time allows I'll cover continuous time Fourier transform and DFT FFT. Okay, I'll try to cover that. So that's all for today's session, guys, and there will be more session on signal and system. After 13th we will arrange some more session on signal system, so that this part can be covered. Okay, because I have not covered the system part even, because there are some more points that I want to tell you about the system part, because I have to cover it in fast way. So that's why some topics are left behind. So anyway, I'll cover those part also. Okay, so thank you, and thank you, take care, and keep attending the classes, keep enjoying the sessions. Thank you, take care, bye.